Welcome everybody in the room and online. We would like to start with the 2022 MS Symposium. And first of all, I would like to acknowledge and celebrate the first Australians of whose traditional lands we meet. In our case, this is the Ngunnawal and Ngambri people, and pay my respect to their elders past, present, and emerging. And I'm very happy to hand over to Ron Cleland, who is the CEO of MS Australia, which is now also including MS Research Australia.
Well, thank you very much indeed. And I too pay my respects to the traditional owners of the land upon which we meet, the Ngunnawal people, and pay my respects to their elders past, present, and emerging. And I also want to pay tribute to all of you in the ACT MS community and to all the wonderful research that's done in this fantastic building. I think when I first came here, I've been CEO now for almost 2 years. It'll be 2 years in about 2 weeks' time. And they said, oh, one of the first things you should do is go and see the wonderful Ohio program at the ANU. And I thought, wow, isn't it exciting that the Australian National University and the MS program are linked to Ohio in America? Of course, I had no idea it was our health in our hands, and what a wonderful concept. And so I was incredibly impressed when it was the first place I visited was here. It feels like home. I did my degree here at ANU. I spend most of my time actually studying rowing and drinking, I think, from memory. But ANU is very much my home. I've got one daughter here and a second daughter who studied here. And I live in Aranda, just up the road. So I very much feel like I'm home. And the ANU Boat Club is about 100 metres from where we're meeting. So it was one of my great haunts. Thank you very much for having me here. I feel very honoured to give the opening address. And I really wanted to talk about, give you a bit of a snapshot of where our thinking is at MS Australia and some of the exciting things that lie ahead. One of the wonderful things about the MS world is that the research is romping on at great pace. And we know that the impact of DMTs has been immense for helping to slow progression and to assist those newly diagnosed. But we really are making progress towards aligning our research, not just in Australia, but globally. And that's, I wanted to share today some of those things. First up, just a quick recap. When I spoke to you last year, we had very much were on top of the merger process of bringing MS Research Australia, merging it with MS Australia. MS Research Australia was set up by MS Australia way back in I think 2004, and it was very successful enterprise. MS Research Australia did a brilliant job at helping to raise funds and pump them into research. And one of the other great things that MS Research Australia did was to help bring the MS research community together. And so we decided that it's actually silly to have two organisations with two CEOs and two boards and two communications teams, and to better align our fundraising efforts across the MS family. So we've done the merger, and we still have an absolute laser sharp focus on pumping money into research and to really build on the work that was done over the past 20 years. And we think we've very successfully done that. And the research is still the very centre of what we do. But we also want to supercharge our advocacy work, and we feel that we've taken that to another level as well. And it's because we've got the strength of the combined organisation. Our research team works hand in glove with our advocacy team, and this has produced a team that really is stronger together. So we think that that's been. I know there was quite a bit of apprehension about what would happen under the merger, but I think it's generally acknowledged now that we are stronger together, and we have retained and strengthened our laser-like focus on the research effort, while strengthening the advocacy side of things as well. So we think we're a stronger team and a really well-focused team. And I've got to say, we've got a wonderful board that really is determined to put the pedal to the metal. We think we're at a real important pivot point with MS. You know, we are making great strides. And because we've come so far so fast, we think what is doable over the next few years is really critically important. And so we're absolutely determined to keep pushing as hard as we can to keep raising funds, pushing it into research, and making the big changes that we need to really improve the lives of people living with MS now, and to help find a way to prevent people from developing MS into the future. So that's a big picture thing. You know, we've got a wonderful strategic plan in place. And as I say, we've really got our tagline, research, advocacy, cure, is really, I think, sums up what we at the national level do. In strong partnership with the member organisations, MS Plus, MS Queensland, MS South Australia / Northern Territory, and MS WA are 4 member organisations. The commitment to supercharge our MS research agenda really focuses on 3 key things. Find those cures through remyelination and repair, support and expand clinical trials for cures and prevention of MS, and develop better treatments and prevent MS via collaboration and shared infrastructure. So those remain 3 key things for us going forward. In terms of trying to pump more money into MS, we approached the government last year and asked them for a partnership program. They didn't give us that, but they did put some money into MS research, and initially they announced a $4 million grant for clinical trials, but very significantly too, they put up $18 million from the MRFF, particularly focused on EBV research. And the very first, it's coming in 2 rounds, and the applications for the first round of that close next month. So we're pretty excited about that. And in addition to that, in the budget, there was some additional research funding for nurses and allied health, not MS specific, but still in areas that we wanted to see greater investment, and also for international clinical trial collaborations. So we do have partnering with an MRFF application, particularly to support in terms of infrastructure, our brain bank. And we have a really fantastic MS Australia brain bank based in Sydney at the Brain Mind Centre in the University of Sydney. That does superb work in providing research tissue, not only for research in Australia, but it provides it globally as well. So without further ado, we're very pleased that this year we've been able to make, in our 50th year, the record investment in MS research, and over $7 million has been allocated by MS Australia in this, our 50th year. 26 new projects, and also almost $200,000 in our very exciting incubator grants and postgraduate scholarships. The incubator grants are a relatively small investment for ideas that really are outside of the box. When the researchers come up with an idea, if they want to get access to a big grant, they've got to have some preliminary data. But how to get that preliminary data? We make these grants available so that they can have some funding to get some preliminary data to enable them, if it looks good, to apply for much bigger grants. And so that's seed funding for great ideas is really important. Some of them will not go anywhere, but some will. And so that's the idea behind those small scale but really important incubator grants. We very excitingly have a number of collaborative platforms, and this gives us a real ability to focus in on specific issues in a collaborative way in partnership with researchers and research institutions. I mentioned the Brain Bank. That's one of our platforms. And in fact, this is the 20th year of the Australian MS longitudinal study, and that really gets patient-reported outcomes. And many of you will be participants in that. People here, anyone in the AMSLS? Yes, excellent. And that's providing a really rich and important source of data that has helped not only strengthen our research and understanding, but also our advocacy efforts. And we're very grateful for your participation in that. Informs online MS portal to improve healthcare for people with MS. ANSGene, which looks at the genes involved in susceptibility and progression of MS. Our clinical trials platform and website, linking people with MS to clinical trials in Australia and New Zealand. The autologous hematopoietic stem cell transplant registry, which we do with St Vincent's in Sydney, is really designed to get better understanding of how effective stem cell transplants are, and to get a better understanding of the risks involved, and also to better understand who it will benefit the most, and so that people who are considering that, which can be, has significant risk involved in it, will it be better than getting a DMT? So we need to understand that better as we go forward, and we are getting a better handle on who will benefit most from that procedure. And finally, Prevans, we're very happy that one of our platforms, our clinical trials, looking at whether vitamin D can prevent MS in those most at risk, and we were able to release the results of that at ECTRIMS, the world's largest MS conference in Amsterdam, just 2 or 3 weeks ago. So those platforms are national collaborative platforms, a very important way of us targeting the research dollar in ways that are highly effective in pushing forward on some key platforms. The 8th platform really is our international work, and we are, thanks to the generosity of our donors, and I know many of you donate to our research program, participate in the May 50K, and this has enabled us to be one of the world's 5 leading MS research charities. And they talk about the big 5, the US, of course, which is really the outstandingly large one, the Canadians, the British, the Italians, and the Australians. That's why when we say Australia punches above its weight and is globally significant in its research effort, it really is. And in fact, I heard someone at ECTRIMS say, the 2 outstanding countries really are the Americans and the Australians in terms of making a globally significant contribution to MS research. But the International Progressive MS Alliance is very much focused on finding treatments for progressive forms of MS, and it is putting substantial funding in, $43 million since the program started. And by 2025, it's believed that in Australian dollars, there'll be over $100 million invested we know that progressive forms of MS are the most difficult ones to manage. We don't really have an effective treatment yet for it, but through the IPMSA and the steerage that's given to it by the big 5, there's some other partners that also are involved in it. We believe that is going to produce some real dividends in the years ahead. For example, just this year we've agreed, I sit on the managing committee of the IPMSA, and our head of research is heavily involved in the scientific research committee. So we have we make a major contribution, not only financially, but also through resources to guide its work. And this year we've put in another $5.5 million Australian to support the next phase of the collaborative network to further develop promising compounds that target critical disease activities and drive progressive MS and brain injury. So that's, I think, a really, really important part of our work. And as I say, it's one of our, we regard that as one of our collaborative platforms. ECTRIMS was very exciting. I was very privileged to be able to go to ECTRIMS. The first time it's been held face to face for a long time. And some of the exciting things I think that were happening there. We were able to release our vitamin D study. We co-hosted a session on MS nurses and the really incredible importance access to an MS nurse can make for people living with MS. The concept of smouldering MS that even outside of relapses, there is activity happening that we may not be able to fully detect and causing damage. That was a great source of discussion. The flipping the pyramid, many of you will be familiar with Gavin Giovannoni and his idea that we need to actually go in early and treat aggressively and so turn the pyramid around. And that concept was, of course, progressing, I think, as we go forward. The other thing that was really exciting to me was the development of the BTK inhibitors, the next generation, I guess, of disease-modifying therapies. There's 4 drugs in stage 3 trials and two further in the pipeline being assessed, and we think that they should, all going well, come on board the next 2 to 3 years. We'll know more about some of the outcomes of those clinical trials at ECTRIMS next year. One of the things that's interesting about this next generation, the BTK inhibitors, is the fact that they could be potentially effective in treating all forms of MS, not just relapsing remitting MS. So we're watching those with great interest. The other really exciting thing I think that's happening internationally and is really important for all of us involved in the research space is how can we better align the research effort that we do. So we've got our Australian collaborative platforms, and there's, they're the ones that MS Australia is involved in, and of course there are others that MS researchers are involved in as well. But how can we better align that not only nationally but globally? And we were very pleased to have helped develop. We've got our own, at MS Australia, we've got our own blueprint for research. And if you haven't had a look at that before, you can look at it on our website, and we think it's a pretty good document. But in the last 2-3 years, there's been a global one developed under the auspices of the Americans, the National MS Society in America. And they've pulled together an international collaboration to develop this global approach to where the research effort should be placed. We endorsed it very quickly at MS Australia because it very much mirrors our own research roadmap. It's a very neat fit with our own one. In America, they've already raised $20 million Australian through lead donors to help support implementation of this global roadmap. But underneath is now agreed pathways to cures, and they talk about pathways to cures plural, because I think it's quite well agreed there will be no one silver bullet, but a lot of silver shrapnel, if you like, which will lead to the greatest progress. A lot of incremental changes rather than one single big leap forward. And that's why they like to talk about pathways to cures plural. The exciting next thing that's happening under that is we are working to develop an agreed a plan to how do we actually align our research activities so that we have, in effect, international collaborations to the fore. How can we align our research efforts domestically in a way which will really focus on those pathways to cures that are set out in the international document. There have been quite a number of meetings already to develop an agreed way of aligning the research efforts. And we are very optimistic that will be signed, sealed and delivered in the first part of next year. And then we can really, by working much more closely together across the global research funding teams, we can actually drive the agenda forward much faster. So that's, I think, one of the exciting things that is happening internationally. And as I say, I'm really, really pleased that the Global Pathways to Cures really matches very neatly our own Australian research, MS research roadmap. One area which I think is actually probably better articulated and quite exciting in the international one, the Pathways to Cures, is in the prevention space. And there have been people in the MS research community who I've talked to who say, you know, really the way to fully end, to put MS behind us is actually in the prevention space. If we can actually go in to not only that, if you can see that diagram on the slide, if we actually, before people get diagnosed, the early clinical signs, the subclinical, and back to the window of risk, way beyond CIS or any major symptoms becoming apparent. If we can get in there and detect people at that stage and treat and manage it and to stop progression there, that effectively would be the fastest pathway to a cure. So that's one area where the international Pathways to Cures document is probably more developed than our own. And we're actually very excited about this space because a lot of the work that we do does look at those, the prevention space. And so we're very keen to talk to particularly the Americans, the Canadians and the British about how we might develop a platform to sharpen the focus around those areas. Coming from, I had 12 years at the Heart Foundation and we did a lot of work in identifying people at high risk of going on to have heart disease, heart attacks, strokes, and making sure that you pick up the warning signs early and manage people before they have a major event. So it's the same sort of concept. So I was actually met with the CEO of the Heart Foundation on Wednesday, just to talk about the concept of it's called cardiovascular risk assessment, and you know how we might be able to look at something similar to prevent people who are at a high, identify people who are at a high risk and then manage them well so they don't go on to develop MS. So that's an exciting area that we think that some global collaboration would be really good. Another area is platypus, and this we're very excited and have had talks with MS UK, the MS UK Society, about their octopus program, which is about identifying existing pharmaceuticals and that may be good candidates for treating progressive forms of MS. And they've done a lot of work to identify likely suspects. And we've got a proposal now that will involve 10 sites to run clinical trials here in Australia. We know that we need to raise a lot of money to do that. We've got some of the money in the bank, and we've got an MRFF application in, and we've got the begging bowl out to raise the funds to make that a reality. So we think that platypus would be an adjunct arm of octopus, the Australian tentacle, if you like, and both the British and we are very excited about the prospect of getting that up and running. Well, I've mentioned the vitamin D study as well, and that's helped advance our understanding of vitamin D. The study itself showed that for people who've had not been diagnosed as having MS, but at least had one relapse, so that sort of CIS phase, and trialing about 200 people were involved in the trial, and looking at 3 ranges of vitamin D supplements, and it sadly didn't show any ability to stop people progressing to MS. But that doesn't mean that vitamin D and UV exposure aren't important. It probably indicates that we now need to look at earlier exposure. It's something that we know something happens, but we need to better understand when that happens and what happens in order to find effective ways of ensuring that we can help prevent MS occurring because of vitamin D or UV underexposure. Interesting, I was at a Research Australia forum at Parliament House on, might have been Wednesday morning, and they released a major report about obesity research, I guess one of the issues there is that particularly about screen time, that young people today don't get sun exposure from a very young age because they are spending so much time on screens and not outside being physically active, and getting a lot less exposure to sunshine, UV and vitamin D. And so we've got some ongoing talks about that. The other interesting thing about that prevention space too, and also from ECTRIMS, was this concept of obesity, overweight, and being overweight and obese, particularly in childhood and adolescence, is a significant risk factor for MS. And so we are wanting to explore that in more detail as well. And there was quite some interesting discussions at that breakfast event at Parliament House. I mentioned nurses. We released earlier this year a really, it took 3 years to do, but we got this, we worked with the Menzies and MS Nurses Australasia on a really significant report, which was released at our research conference in Hobart earlier this year. It really shows that if someone with MS gets access to an MS nurse, the outcomes are dramatic in terms of accessing appropriate services and adherence to medications, and it reduces the avoidable hospital admissions, reduces the need for further specialist care. In fact, for every dollar that's invested, there's a $64 saving to government down the track. So it's just a huge, it's in that rare space that's not just cost effective, it's what the health economists call cost dominant. I mean, it really is the intervention that Harrods would sell you. Yeah, and so but the tragedy is that we're losing MS nurses. Our MS nurse workforce is in decline, and we are having talks with government about how to arrest that and turn it around, because we know that getting access to an MS nurse is of great benefit to people living with MS, their families, friends and carers, but also to government coffers. And so we're working very hard to try and turn that situation around. NDIS in the advocacy space, I hope you might have seen some of our campaign, particularly during budget week. We at highly effective rates, we were able to plaster the Canberra airport with our advertising as politicians arrived for budget week, all above the baggage carousels and all around the airport. We have a really well-targeted campaign, particularly to help the people who run the NDIS better understand MS, better understand the circumstances and challenges facing people with MS. We know that about a third of people with MS have NDIS packages, and largely those packages are good, but getting access to the NDIS can be a very hit and miss, and it shouldn't be. So we want to establish a neurological advisory group embedded within the NDIA advisory structures, and we're having, I think thanks to the campaign, we're now in talks with the NDIA, and hopefully we'll make some progress towards that goal as we go forward. In terms of what we're doing internally to ensure that the approach we take with the consumer voice is to embed it in all we do, and not have an advisory body over here that we consult from time to time. It's a bit like Ohio, you know, the voice of people with MS is embedded in all we do. You know, with most of the people on our board have MS or have a close relative with MS, and they have that lived experience. We have staff members who have MS. We have other staff members who have autoimmune conditions. We have, and the concept of our National Advocates Scheme, we're looking at how we can strengthen that going forward. And there's a workshop next week, which we hope to use as an opportunity to see how we can grow that national advocates approach so that we can get a better voice into Parliament and our political representatives. We're also looking at creating a lived experience expert panel to help inform our policy work. That concept, I think, we hope to launch next year. We have based it on some work that we did I did previously in another organisation, and which worked really, really well. So we're hoping to, I'm very proud of the work that's been done in our policy area. We've got some really top-notch submissions, and we're just looking at a way where we can ensure that the voice, the lived experience voice, continues to be strengthened in all our policy work. I was just going to finish up. I've probably spoken too long. I hope you haven't fallen asleep. The other advocacy opportunities for us, we are very much looking about aged care agenda, and we've got a submission going off today. We are very conscious that there's still, if we're getting very good at delaying progression of disability in MS, but that means people will be acquiring disability after the age of 65 and therefore not qualifying for the NDIS. That's a total inequity, and we have a major goal of making sure that barrier is addressed by government. Also in aged care, people don't get the same support as people who access the NDIS do. We've got ongoing active engagement in the aged care reform agenda, which is really important for us. And also that sort of tier 2 support. If you can't get access to an NDIS package, then what is available to support you? And that's another gap in the current range of services available to people living with MS. We also have a wonderful parliamentary friendship group for MS, and we're looking at ways we can enhance that and help use it as a voice for MS within the major parties in government. Finally, I was going to mention the fact that we've got 25,600 people with MS. We're going to update that figure in January, one of the things that we are very conscious of is that prevalence rates have been increasing in North America and Europe, and dramatically increasing. We will find out in January whether that's the case in Australia or not. We suspect it may well be, that will be a major wake-up call for government to spend more attention on MS research, and also the challenges of people living with MS through NDIS and aged care. So watch this space, that prevalence data, and also the cost of MS in terms of both direct and indirect costs to government. We'll be releasing those in January. So finally, a big thank you from me to you. As I say, all the work that's done here is I feel is exciting, it's relevant, it's potent, and the higher program is such a great concept. Such a great concept. It really embodies everything that's important in the MS space. So thank you to you. Thank you to your involvement. In this, our 50th year, my pledge to you is to keep that pedal right on the metal in our research, our advocacy, and our education work. So thank you very much for inviting me here, and have a great day.
So Rowan was mentioning the advocacy group, and our next speaker is actually a recording by Vanessa Fanning. So Vanessa has spoken at the symposium in the past. She's one of ours. She is an active member at the Ohio team, and is also a representative in these advocacy groups internationally. And she just came back from the MS International Federation, and prepared a little video about what was discussed there.
Join you at the ANU MS Symposium in person. I'm so grateful to our colleagues at the ANU for the generous support that they give Canberra people with MS, for their genuine commitment to involving patients in their research, and for their dedication to solving the unanswered questions in MS and working for a cure. For those who don't know me, I'm Vanessa Fanning. I was diagnosed with MS in my late 40s, which is quite a while ago now, and I'm the co-convener with Mary Webb of the ACT People with MS Taking Control group. I also set up the Canberra Region MS's Facebook page. So if you're not already connected, do have a look at the Canberra Region MS's Facebook page and join us. I'm a keen participant in research, and I'm involved in the health experience team of the, Ohio at the ANU. I'm also the chair of the People with MS Engagement Coordination Team of the International Progressive MS Research Alliance. Sorry, that's quite a mouthful. That team comprises 7 other people with MS drawn from all around the world. And through my work with the Alliance, I've been nominated to the Patient Advisory Committee of the MS International Federation. Again, this committee is comprised all of people living with MS drawn from all around the world. The MSIF is the only global network which brings together MS organizations, volunteers, and people living with MS. It has 47 member countries, but its links are much broader. I have to say it achieves amazing things with a very small group of staff. The first global networking meeting for 3 years was held last month, and I was able to attend that meeting, hence my interest in giving you a bit of an update on the MSIF and the work that it does. Probably the best known creation of the MSIF is the Atlas of MS, which actually has its own website, which you see here on this slide. You can see the wealth of data that is collected on the incidence of MS. The 2020 data also tells us that the incidence of MS is growing quite significantly, which is pretty bad news. What the Atlas also highlights is the many barriers and inequalities that people with MS face in accessing diagnosis, treatment, and care. We're very lucky here in Australia. We generally have access to early diagnosis. We have good access to neurologists. We have world-class researchers, many of them funded inter alia by MS Australia. And there is growing recognition of the very important and valuable role of MS nurses. Certainly, we have excellent access to disease-modifying treatments. If you were to be diagnosed with MS, say, in Uruguay, Egypt, India, it would be a very different story. Speaking of disease-modifying treatments, I'll note here that the Atlas also lists all the disease-modifying treatments. The very most recent ones may not be included, but they're nearly all there, and it classifies them according to their efficacy. So this is a very useful resource. In short, the Atlas is a powerful source of information, particularly if you're recently diagnosed. And for those of us who've been living with MS for a while, it's a great advocacy tool. I just wanted to give you a quick look at the data from Australia in the Atlas, which tells you probably what most of you already know. MS strikes mostly women in the prime of their life, with implications for their careers, relationships, families and children, and indeed their very identity or sense of identity. The MSIF webinars are really worth checking out. They always feature eminent researchers, and they are usually moderated by people living with MS. The most recent one on pain was broadcast only a week ago. The webinars are always recorded, so you can watch them in your own time. which is just as well because they tend to be broadcast at 2 or 3 in the morning, Australian time. But if you register in advance, you can submit questions to the researchers before the broadcast, and they will answer them in the broadcast so that you get to see your questions and hear the answers broadcast later. The particular webinars that I've mentioned in this slide are all broadcasts featuring the research breakthroughs of the International Progressive MS Alliance, and they're pretty interesting in my view. The importance of recording and analysing patient-related outcome measures, or PROMs, is now being recognised more fully all around the world. The ANU, of course, has been a leader in this field. The MS International Federation is leading a major PROMs initiative, which is a world first because of its scale and breadth. This slide tells you what it's all about. The project is really looking for large numbers of people with MS to participate. So I urge you all to think about getting involved, which would be, for example, by responding to written surveys. The significance of recording patient-related outcomes was highlighted in a recent scientific publication on neuropathy. This clinical investigation found that grade 2 neuropathy was reported by clinicians in only 28% of patients, while 67% of patients in the same study reported quite a bit or very much tingling or numbness. So the agreement between clinicians and patients was really poor. So the study concluded that care must be taken to select and include patient-reported outcome measures in clinical assessments to enable accurate identification of genetic and other risk factors and simply to obtain an accurate picture of what's going on. I wanted to just briefly show you on this slide a summary of the MSIF's key goals and strategies. I won't read it to you because you could already see that for yourself, but if I can sum it up, the MSIF is all about the unmet needs of people with MS all around the world. It has a very special role to play in capacity building in less well-resourced countries. And I should mention that Australia is playing and has played a very important role in finding ways to improve access to disease-modifying treatments for countries which are less well off. There's a page on the MSIF website which is called the Resource Hub. It's a great space. This slide outlines the many topics dealt with in the Resource Hub, including COVID, aging, mental and emotional health, relationships, etc. Some of the material is put together by MSIF staff, and a lot of the material is contributed by member countries. Whatever the source, you can be confident that this information is reliable and has been subject to careful review by qualified professionals. There's also a wealth of resources which are available to organisations or individuals wanting to organise or participate in awareness-raising events or fundraising events, including some great digital material. And that's available to any or all of us. So if I can just sum up, we have great resources available to people with MS through MS Australia, and much of our information and research is shared with the MS International Federation. However, if you're interested in the resources offered to people with MS in, say, the USA or Denmark or the Netherlands, it's available on the MSIF site. It's also pretty sobering to realise how tough life is for people with MS in the less well-resourced countries. You can find here the latest developments in global research and data collection. So if any of this seems interesting, and if you want to connect to the global community, then I urge you to visit the MSIF site and subscribe to the updates so that you can see what's available and what's coming up. Thanks for the opportunity to talk to you today, and do enjoy the symposium and especially the camaraderie. Bye.
Yeah, thanks, Vanessa. If you have questions, so that you can always email her. And she's currently on her way overseas to one of these meetings. So before we go into the morning tea break, we have one more speaker. And it's my pleasure to introduce Chiara. Chiara, if you come up. So we made it a point to always have one person with MS describing their journey. And this year we invited Chiara because she's the newest member of the MS Community Engagement Council. Yeah, and I'm very interested to hear her story, and we're going to do it a little bit as a discussion.
Yeah, Anne, because I have a bit of brain fog, so Anne has agreed to prompt me if I seem to forget something. So thanks, Anne. So I've been invited to speak about my diagnosis story, and it's actually a really strange one. But now that I've heard what you're talking about today, it fits really well. So I was diagnosed with MS 11 years ago when I was 29, but it's very unusual because perfectly healthy, perfectly fine. And then one day, actually one night, started acting very strangely. And I don't remember any of this. My parents told me all about it. They took me to the emergency department. And at the time, they thought I had a brief reactive psychosis. I spent 2 months in a psychiatric ward. And then when I was dismissed, I had to go see a neurologist. And he said to me, "You have MS." And at the time, no symptoms whatsoever. So they put me on methylpred, put me on Copaxone, and, took that every day. Still no symptoms. About a year later, started getting pins and needles in my hands. So go off to the emergency department because that's what I thought you did when something was wrong. And they saw that I was in the psychiatric ward, so they chucked me back to the psychiatric ward. So this happened for quite a long time. And I was quite perplexed as to how someone who's 29 with no history of mental illness, no contributing factors in childhood can all of a sudden get a psychosis. So we found out 6 years later through a bit of self-advocacy and really knocking down doors and going, I think something's wrong here, that I actually had a hyperactive thyroid. So that got treated and all my manic symptoms went away straight away. But what I found was that with the MS, because I had that psychiatric history on my medical record, every time I would talk about something that I was experiencing, because all my symptoms are subjective, got brain fog, cognitive difficulties, I kept getting chucked back to psychiatry. And what was really, really interesting is that when I would come across a young doctor, he would look at my health record and he's like, "But you have MS. This is a symptom of MS. Why are you here?" And I'm like, "Thank you. Can you please tell the other guy that?" But it was actually the older ones that would just be like, "Oh, sorry, this is a feature of your psychiatric illness." So yeah, it was actually quite a long journey to get the thyroid condition sort of recognized. But it was also quite interesting for me because I hear from a lot of other people with MS who go a long, long time with symptoms that they can't explain, trying to get a diagnosis. Then they do. Well, I had the diagnosis and I still couldn't get taken seriously about my MS symptoms. So I'm glad about this topic because I think it is very, very fitting. Have I missed anything?
Yes.
I probably have.
No, so perfect. Thank you. So you said you looked a little bit into these psychiatric thing, and
Yeah.
you actually took on some roles there. Can you maybe talk
Oh,
about
yeah.
this?
So, yeah, I did. I actually ended up working as a mental health peer worker because at the time I did think I had bipolar disorder and I did suffer from a very, very severe depression, which is why they gave me bipolar, mania, depression. So I did work as a mental health peer worker. And it's interesting because in mental health space, peer workers do a lot of advocacy. They talk a lot to psychiatrists about the experience of what it's like to have a mental illness. But when I sort of was looking navigating my way around the MS space early on, I just found that there wasn't a lot of that. And, you know, you can, if you're having problems with your mobility, you can see that. But how do you know what it's like to have pins and needles? How do you know what it's like to have brain fog? How do you explain when you know what you want to say, but something else comes out of your mouth? That's subjective stuff. You really need to hear it from the horse's mouth, really, because there's no other way of capturing that data. You can't see it. Yeah.
So yeah, what I find really interesting is like there's two aspects of your story. The one is the like not having visible symptoms and then having this need to explain yourself in not measurable ways. And the other one is these being dismissed.
And in my career, actually, it's quite funny because I used to be in statistics. So I was measuring everything. Like, I'm like, well, you know, like pins and needles today, this much. It's just my nature to do that. So I was collecting all this stuff. I'd just see my neurologist. He'd be like, how's it going? I'm like, oh, I've got all this info. Not interested. How's your MRI? MRI is great. You're fine. Go home. So yeah, it's really interesting. I'm very happy to hear that this has been spoken about, because I don't know about you, but I'm very meticulous about like how I'm progressing and things like that.
Yeah, no, I think that fits very well. I mean, we just heard from Rowan that there's a lot of effort trying to bring in these aspects and these self-reported symptoms and this whole layer of symptoms. And of course, this is one of our big tasks in Ohio to include the lived experience in our research. You also, can you maybe describe a little bit what kind of symptoms you're dealing right now and how you overcome this?
Yeah, so my pins and needles have never gone away, and now they're in my left hand as well. Cognitive problems which fluctuate. I do have sometimes some speech problems, swallowing problems, particularly when I'm tired. I have had the good old MS hug. That's interesting. Like a girdle. Like, and I am starting to get some pins and needles in my feet, but mobility wise, no problem. Oh yeah, fatigue. It's so normal, I forget about it now.
Yeah, so in our pre-discussion, you told me that especially this cognition is quite impairing you, and that you took some actions to overcome this, and maybe you can talk about this.
Yeah, so I actually did some cognitive remediation, which is fantastic. So I'm a bit of a nerd. A lot of my hobbies are around reading, puzzles, stuff like that. And from cognitive remediation, I sort of learned that it's a use it or lose it situation. So you want to sort of I want to exercise my brain to make it 80%. Don't go too far, because then the next day I'm going to pay for it. But just always exercising to sort of get my stamina up. So I love board games, have a house full of board games. And a lot of the things that you do when you do a neuropsych test are like my games. So I started a board game group at MS Australia. So it's a social fun, but also a little brain workout if you want it. But we also have some quite relaxed games as well. But yeah, it's sort of that sort of creative way of giving our brains a bit of an exercise.
Yeah, wonderful. So thank you, Chiara. I think again we can grab her during the. And this link to your board game group actually gives me a good leeway into the MS Community Engagement Council, which is basically here for you. No? So if you're not aware of us, please reach out. There's a lot of different activities going on, and one of that is the Christmas party, and I think that's your prompt. Oh, just come here so that the people online hear you too.
I forgot to mention when this group runs, every second Saturday of the month at Royal House.
So just to translate that to the online audience, so the board game group is every second Saturday of the month at Gloria McGowan House, 1:30.
Hi, I'm Jessica Draper-Jones, and I also am a member of the ACT MS Engagement Council. I'm new too. But I'm here to just invite you all on behalf of the council to join us for a Christmas party, which is also being sponsored by Hands Across Australia, Canberra. No, Hands Across Canberra. Thank you, Hands Across Canberra. And the Christmas party is going to be on the 15th of December. It's a Wednesday from 4 to 6:30 p.m. at Deacon and Me, 7 Giles Court, Dixon. So there's handouts for those of you who are here to grab. Thank you, Deacon. There are handouts. And if you go to the Facebook page, Vanessa's Facebook page, you can also see some more information for those of people who are viewing online. And please come. We don't have, we have access to the names and email addresses of people who are involved in the games group and the exercise group and the art group, but we don't have all of the ACTs access to their email addresses. So come along. If you haven't had the opportunity to contact other people with MS in Canberra, in the Canberra region, take this opportunity and celebrate Christmas. Thank you.
Thanks everyone for coming for session 2. I'm the chair, so I'm Jo Lane, a clinical psychologist and research fellow as part of the Our Health in Our Hands project. I'm not the most technical savvy person, so please forgive me before I make mistakes, which are inevitable. So I'm going to introduce all the speakers in the next session as a quick bio, so you know who they are, and then we'll, just to save time instead of doing it at the front of each one. So we have Katrina Chisholm, whose background is in health information, working in hospitals, in the WA Health Department, in the Hospital Authority in Hong Kong, Department of Health and Ageing, Independent Hospital Pricing Authority, and Engineers Australia. She was diagnosed with relapsing remitting MS in 2003 and acute transverse myelitis in 2011. And she's also involved in Our Health in Our Hands, so she's going to talk about that today. Jane Desborough has an ARC DECRA Fellow and Senior Research Fellow here at the National Centre for Epidemiology and Population Health. She's a mixed methods researcher who works closely with patients, clinicians, and policymakers to conduct research that is not only responsive to the needs and preferences, but also to targets quality of outcome improvement. She leads the Our Health in Our Hands experience team, which has more than 20 researchers and half live with MS and type 1 diabetes. Her project is really about embedding the experiences, the lived experiences of people with MS and type 1 diabetes into every aspect of the project, right through from inception to implementation. She's also a leading researcher at the Australian Department of Health, looking at rare diseases. We have Robin Weiger, who is a PhD candidate and research officer at the School of Computing. He's also part of Ohio in the big data team. He works on diagnostic and prognostic machine learning models for neurodegenerative diseases. And before he moved to Australia, he graduated with a master's in cognitive neuroscience at Maastricht University. Sorry if I pronounced that wrong, in the Netherlands. Ted, Professor Mattis, he came to ANU as a PhD student in 1981. So he's one of the most enduring researchers here. He and his group work on diagnostic instruments for eye and brain diseases. He's got considerable experience commercializing research outcomes as well. He is also a founding chief investigator of Ohio and works on both MS and diabetes. And he's currently the head of the Canberra-based Vision ACT Action Research Consortium. You will not believe the acronyms that I'm reading through here as I read this. And then Anne Bruceler is the head of the MS stream. She is the group leader at John Curtin Department of Immunology and Infectious Disease and has been since 2014. And I grabbed this off the website this morning. So she focuses on investigating T helper cell differentiation. There's lots of big words there for Jo, and the differentiation of Th17 cells. I'm not going to read all that. So she'll introduce herself as well, but she's certainly the lead of the MS research here in Ohio. And I'm a research fellow, clinical psychologist, love what I do, and I think it's time to move on. So I'm just going to share this very short video on Our Health in Our Hands, and then our first speaker is Katrina.
In 1924, construction began for the Sydney Harbour Bridge. In order to keep it stable, without the need for temporary supports to be built in the deep water of the harbour, the top steel arch was assembled by adding material to each side at the same time. Throughout the 6-year process, 2 construction teams from the 2 different sides worked together, slowly adding pieces of metal to each side until the 2 parts finally joined at the top, creating one continuous arch. If the construction team hadn't built from both sides simultaneously, it just wouldn't have worked. The bridge wouldn't have had enough support, and it would have been far too dangerous for the workers. So, it was this collaboration between 2 opposite sides that really allowed the bridge to be made. But why have I been explaining this to you? Well, something similar is being researched at the College of Health and Medicine at the Australian National University. Many researchers in Australia are investigating the effects of chronic diseases on our bodies, but very few actually involve the patients who are living with these diseases and listen to what their needs and desires are. While researchers can be considered experts in the diseases they study, it is also very important to recognise that people living with disease have a level of expertise that others will simply never have. This is why researchers at ANU have developed a model of standard practice for health research, where patients and those living with disease are directly involved in the study. Titled, "Our Health in Our Hands," these scientists are bridging the gap between researchers and their subjects and working from both sides simultaneously to reach the best outcomes for all. Much like how the Harbour Bridge was built from both sides, combining workers from 2 separate teams, these ANU researchers have combined 6 different teams to build incredible products and research outcomes for the public, with the public. One of these 6 teams is comprised mostly of people living with multiple sclerosis and type 1 diabetes, and in this collaboration, they've been working on sensor platforms for monitoring the progression of these diseases. Their work focuses on diagnostic and health monitoring devices, using complex bioscience, sensor technology, data analysis, and machine learning. They're also working on the development of portable acetone breath monitoring devices, a new multifocal eye test for diabetes eye research, and the collation of big health data that can be turned into knowledge about disease management. Their innovative approach of collaboration has even involved asking patients to create a wish list of improvements to technology to improve their experience with disease, and including them in the design of their research agenda. So, like the Harbour Bridge construction, collaboration between 2 sides of the project has been absolutely crucial to the project's success. It is hoped that this research model can be applied elsewhere in health science and beyond. That's pretty clever stuff. Thanks, ANU. This video was produced on the traditional lands of the Ngunnawal and Ngambri people, who we acknowledge and celebrate as Australia's first scientists. If this research excites you, come and learn more with us at the College of Science, ANU.
So welcome, Katrina. Thank you.
Thanks, Jo. Why people with MS should get involved in research. I got involved in the health experience team and have been involved since 2018. And since then, I've also worked on the Import MS thing with the University of Tasmania, developing the portal for people with MS, and also another thing at Monash University on depression with MS, which has gone into a bit of abeyance due to COVID. There are different types of involvement that people with MS can get involved in. Is participation in clinical trials. In 2008, I participated in TED's trial of eye reflex movements, and so I'll be interested to hear the progress with that. Participation in research committees. As I just explained, I'm on the health experience team, but also with the University of Tasmania and Monash University, providing information via surveys. The Australian longitudinal MS study actually originated here in Canberra with Rex Simons at the Canberra Hospital, and then later moved down to the University of Tasmania. And that information provides is an enormous amount of data to people involved in research. And the Import MS is hoping to be able to link your personal data that may be on the longitudinal study into the portal for you to access that information. And it's important that people do participate in these surveys, otherwise that information doesn't get recorded. And clinicians are not very good about sharing information, even with patients. So that participating in focus groups. When we got funding for the MS Toolkit, one of the things that we held was focus groups. And from that, those focus groups, a lot of information was generated, which became the precursor of quite a bit of the information done with the Our Health in Our Hands health experience team. And also giving papers at conferences, seminars and symposiums. Why should people with MS participate in research projects? We have the lived experience, and I participated in an interview with Joe, which I'm apparently being shown at the SAM, but not here. But one of the reasons I got involved was I was at the second MS Symposium one of the researchers sitting in front of me turned around at the end of the time and turned around and said he'd been researching MS for 7 years, and this was the first time he'd ever met people with MS. And I thought, well, that's a very telling process, because how would he know whether his research was going to be of benefit to anyone if he had never met anyone with MS and doesn't know all the different symptoms that we have? No one has the same symptoms. We all present with different reasons why. I mean, Tiara talked about her problems with being diagnosed with a psychiatric disorder and then constantly put back into the psychiatric system without being treated properly for her MS. And there's a desire to help researchers to find solutions for people with MS, whether it's in better medications and disease-modifying therapies that can assist us, or whether it's ultimately to find a cure for MS or to regenerate the demyelination of our nervous system. We want to encourage more research in disease-modifying therapies to improve the lives of people with MS. If you're diagnosed, you're newly diagnosed now and you go straight on to a disease-modifying therapy, you won't have the same level of disability as people like myself, who was diagnosed in 2003, although my symptoms have been going on since the 1990s, because there was very little disease-modifying therapy. I'm the child of a person with MS, and my father had MS from the early 1960s onwards to when he died in 1980. There was no medication in those days. There was no way of being able to have an MRI. That wasn't invented then. CT scans weren't available. So it was very hit and miss. And I think the only thing that they could do was a lumbar puncture and look at the cerebrospinal fluid. And our information can assist researchers in finding a cure. And that's what we all would like to see in the not too distant future, because it's not going to repair my problems, but it will help people to prevent them getting MS in the future, and that's something that's of great importance. I'd like to thank the ANU for funding our Health in Our Hands MS project and getting people involved, people with MS involved in this research, because it's very important that we have a say in what's going on, because we can give you advice about whether things are relevant to us or not relevant, because we wouldn't like to see people going down the wrong track, then having to reverse their direction because they haven't spoken to anyone with MS, and we can say, no, that's not relevant, or yes, that is, keep going in that direction. Thank you.
Lovely. Thank you, Katrina. Thank you so much. So I'd just like to acknowledge the Ngunnawal people whose land that we meet today and pay my respects to the elders past, present and emerging, and any lands that the people online are on today. We live in a really beautiful place here in Canberra. So I represent a team today, and I really want to thank each member of my team. It takes a village to do research. It takes a village to do anything. And here I've got Bruce Ludd, Nick Sherbian, Christian Leweck, Robin Lucas, Carmel Poyser, Yishuan Xiao, myself, and those little yellow people. I couldn't put all participants there because that's a breach of confidentiality, but that's our participants. We can't do this research without all those happy yellow faces. So I just really want to acknowledge the team that I work with and all the people in the MS community that embrace our work and are just so generous. So I thank you so much. So I'm going to update you on the ACT-MS cohort study. Most of you are very familiar with it, but in case you're not, it's a longitudinal study involving people with and without MS. So the difference with our study compared to the one in Tasmania is we actually have people without MS because we want to see over time what happens with health and well-being for people with and without MS. So that's how ours is different. And essentially you do some online questionnaires. We take a blood sample once a year. And then for people with MS, you do an expanded disability status scale or EDSS, and we measure your height and weight for all participants. And it's been really exciting to announce that we've just started our second year annual review. So people come in for the initial appointment, which we describe as the baseline. They have a yearly follow-up, and we've hit our first second year annual review. So people have had 3 samples now, which is super exciting. So again, we thank everyone who is involved. Unfortunately, I just can't work out how to do all this, but essentially we have 81 participants now. So we have people with MS and without MS. You can see we have a lot more people. That lighter gold color is people with MS. Sorry, the lighter color is females. And we know that 75% of people with MS are females. So that's why we have a very strong female component in our sample there. But there's a really nice distribution of MS and non-MS in our cohort study. As far as types of MS, 62% have relapsing remitting, 10% have primary progressive, 10% have secondary progressive, 5% progressive relapsing. And don't know an other just means that they weren't given a diagnosis other than MS by their clinician when they were diagnosed. So the study participants, unfortunately, you can't see the bottom. I could try to move stuff, but then it'll be in the way and the other way. But essentially, we have a nice distribution across all the age groups. We need more people without MS in the 40 to 49-year-old age group. And we have quite a few younger people who don't have MS, but we have no concerns about that. That's absolutely fine across the longitudinal study. So moving forward with the cohort study, Anne's going to talk about future research. So as I said, we're commencing our second year annual reviews. We're always recruiting more participants because it is a longitudinal study. So we'd love to have more people both with MS and without MS in the study. And we've started that, we started a site at the Sydney Adventist Hospital known as the SAN, and we're starting to recruit, and hopefully we'll do our first clinic in December, which again is really exciting. So we'll have a whole new group of participants in the Sydney site. Now I'm going to talk about fatigue in MS, and it's more than feeling tired. It's that overwhelming sense of tiredness. And I can see, I don't know if it's the dark room. Some people have just having moments, and that's okay. Please stand up and move around. I know it is difficult. So feel free to keep getting up, get a drink, and do what you need to do to be comfortable. We know it's the most common and disabling symptom of MS. Up to 95% of people with MS describe it as their most disabling and upsetting symptom. It's across all stages, all types of MS, and it can be a feature of a prodrome. So before someone's diagnosed, they can have fatigue and not actually know it's MS until later on. It has cognitive, emotional, and physical components to it, and it impairs quality of life. So there's many causes of fatigue, and multiple sclerosis is one. Psychological health, a key feature of depression is fatigue. The environment, lots of different comorbid conditions, physical health conditions, obviously sleep disorders, medications, etc. So we know fatigue is complex anyway, let alone in MS, it's even more complex. And we're trying to work out the causes of fatigue. And to be honest, that little diagram was just like a taster, and I gave up on the arrows because the arrows go in every direction. I was just trying to show you that it got messy. So everything is interrelated, multi-directional, perpetuating. So fatigue is a problem, and that's why it's such a big problem in MS. So there's a lot of research on the effect of, well, not a lot, there's research on the effect of dietary intake on MS-related fatigue. And there was a systematic review in 2018 that looked at the effect of having a holistic dietary intake and the subjective perception of fatigue in adults with MS. So in this systematic review, they found 4 studies that met the inclusion criteria, and they had paleo diets, low-fat diets, and a low-fat plant-based diet. And if you know anything about research in MS and diet, you'll know it's a minefield. And there's not any concrete evidence now about diet. It says it has the potential to lower fatigue in MS, but there's no solid conclusions. Essentially, the take home is a healthy diet. So fruit, vegetables, what is good for your brain would be good for MS as well. So I'm not going down the rabbit hole of diet and MS because I know it's troublesome, and I'm not chasing that rabbit down. So I'm not going down there. But what I want to talk about is a new study. Now, when I did the arrows before, initially it was like in one direction, but actually everything is multi-directional. And what I want to look at is the impact of MS fatigue on diet. So if I'm fatigued, do I eat differently? Do I prepare the same meals? Do I cook the same way? Do I go to the shops as much? So we want to find out that relationship. So I'm not going down a rabbit hole. I'm looking at the impact of fatigue on what people eat and drink. And I'm not going to use the word diet anymore because that has connotations. I'm saying what people eat and drink with MS. So this is my medical student and Nick Shervin's medical student. Her name's Shami Christian. She's a medical student, so she's doing her exam. So unfortunately, she couldn't make it today. But the project for her that we're looking at is what is the impact of MS fatigue on what and how people with MS eat and drink, and how is it managed? So are there strategies people use? So when I'm fatigued, I cook 100 meals, pop them in the freezer, so I have that ready to go. So working through that. We have an excellent research team on it, and it's myself, Nick, Christian, Carmel, Yishwan, and you can't see the most important ones down the bottom. They're Lucinda Black, Cindy Black, and Angela Begley at Curtin University, the nutritionist and dietitian. So we've got them on team as well. So we want to look at, explore and identify the impact of fatigue on what and how people with MS eat and drink and how they manage this. And we're going to use the findings to inform dietary and fatigue management, education support and intervention programs, and the development of educational resources. So if we find some really nice results, it could be encouraging, the NDIS to do more related to diet, for example, for people with MS. So I need people who are 18 or older who have MS and either current or past fatigue. We're looking for 10 to 15 participants. And to be involved, it involves completing a 20-minute online questionnaire once you've done the consent process, and we'll find out some basic information about your MS, about your demographics and your fatigue and mood. And then there's a 60-minute one-on-one interview over the phone or Zoom, and that will be audio recorded and transcribed. I will ask participants if we can contact their treating doctor as well to get confirmation of their diagnosis, but that's not essential. So if you're interested, contact me. There's actually a sign-up list out there. We're doing the interviews between the 7th and the 16th of December. I know that's a very limited time frame, But the goal, because it's a medical school project, we're trying to get the interviews in December, transcribe in January, and get it ready for later after that. So if you're interested, come and talk to me. I'd love to talk to you about the studies. So I really want to thank all of our participants, all of the people who support our participants, who either drive them in or help them out. I really appreciate it. All the supporters of Ohio and MS research. It takes really a village to do these things. Toby's already gone, but Toby helped with all the media and Eventbrite and all those things. We can't do that without him. All the researchers across Ohio, and I really do work with an excellent research team, and there's no way I could do any of this without them. And in particular, Carmel, who does all the emails and chasing. So if you don't know who Carmel is, she's in the corner there. So you can thank her for all the running after everyone to make sure this happens. So I really appreciate it. So that's me done.
Hello, everybody. My name is Robin Vlieger, and I'm a PhD candidate in the School of Computing, where I work on prognostic and diagnostic models of neurodegenerative diseases. Today, I will be talking about a literature review we've been working on, with the very long title, "The Use of Event-Related Potentials in the Investigation of Cognitive Performance in People with Multiple Sclerosis." So, why are we doing this? Why were we investigating event-related potentials? Well, if you look in literature, there's about 43 to 70% of people living with MS that are reported to have cognitive deficits. This can lead to reductions in quality of life. And the problem is that a lot of these cognitive deficits can actually occur independently from physical problems. So, for example, the EDSS, of course, a lot of people say that it's too much focused on just like physical performance. So it's actually really good if we could find a clinically useful measure that can really pinpoint these cognitive problems, because it would be a more holistic assessment of the disease status in a person. So, what is an ERP and how is it measured? So this is me. Like any other good scientist, I of course do everything on myself first. And as you can see, I'm just sitting in a chair and I'm having an electrode cap on my head with all these little electrodes, 64 of them, and I'm holding a button box in my hand. So what happens is that we will do a particular test with somebody. So this is a test we've been doing ourselves. I'm being shown a blue square. Then after 2.5 seconds, either an X or a Y appears. The X appears, I have to push the button corresponding to the side of the X appearing, so left or right. If a Y appears, I actually have to withhold my response and just wait until the Y disappears. And then we'll just do that over and over again. So what you get then is a time-locked response of your brain basically to the stimulus. So you see there's a P1, an N1, and these components are all basically named after whether they're a positive or a negative component and when they occur. So a 1 just refers to it happening 100 milliseconds after the stimulus has been presented to somebody. And the first ones are all basically just the stimulus entering your brain. So of course, first you have to actually notice it and then like kind of orient to it. And then the later you get more of the cognitive components, because now you have to make an assessment of what is going on. And we can basically just measure that with these electrodes and average it out, and we get a good idea of what is going on. We can do that, we can quantify it in basically 2 ways. Either you just look at the latency, so when it happens. So if there's a difference between the latency of a person who doesn't have MS or Parkinson's or Huntington's or whatever, or somebody who has a particular disease, you can say like, well, we can see that there's something happening, and then we can see like if that changes over time. So if somebody has been diagnosed a year ago or 10 years ago, then we can quantify that. Of course, you can also do it potential like a millivolt wise, so we can actually see the amplitude of the component. You can say like, well, is there a reduction in amplitude? Is there an increase in amplitude? Stuff like that. But there's a bit of a minefield. So today I won't be talking about that. So in the literature review, the first thing we did was just look into all the work that's been done into ERPs and multiple sclerosis. So we found 603 papers in the data or studies in the databases. And after removing duplicates, because of course we do that through several databases, we removed 300. So we have 343 left. Then we just looked at the records. We screened them. We read the abstract. We read the title, and we excluded another 212 just based on them not being relevant to what we're doing. So then we went on and we read 131 of them. And then we saw that there were 71 of them that didn't really pertain to the question we were trying to answer. So some of them were actually other literature reviews. Some of them had wrong study design. So in this case, we were only looking at adults with MS. So there were actually studies into children and that kind of stuff, but that's a whole other kettle of fish. So we removed these studies from the literature review. And so there's like a whole load of them of different reasons why this would not actually help us answer the question. So in the end, we had 60 studies left. And yeah, that's what we analyzed. So what we did was we looked at all kinds of different things. So we looked at whether a study used visual or auditory stimuli. So for example, what I showed you before, that was a visual experiment, of course, because you're showing something on the screen, you have to respond to that. But there's also, there are also experiments in which you're just being, you just hear a tone, and then you hear another tone, and then you have to distinguish between these two tones, for example. So there's a lot of different ways of how people have set up experiments. So that was the first thing we actually looked into. What would be better, just using visual experiments or auditory experiments? And we found that, well, first of all, there's way more auditory experiments than there are visual experiments, but the visual experiments actually seem to distinguish better between controls and people with MS. So what you see here is an effect size, and it's really just a measure between the mean of one group and the mean of other group, and we want to see there how far these means are apart. So if you look on the x-axis here, you see it's 0, 0.1, 0.2, and that's basically the effect size. If you have an effect size of under 0.2, then we'll basically say, well, don't bother. If you have an effect size of above around 0.5, then you would say like, well, this is a medium effect size. We're getting somewhere. If it's 0.8, then you're like, well, now we're really in territory in which this is pretty amazing. After we looked at these visual stimuli and the auditory stimuli, we actually just grouped all the experiments together to see if there was a particular experimental paradigm that would work best. So I won't go through all of them except for one. If you look at the oddball experiment, you see that there's way more oddball experiments than other experiments. And an oddball experiment is a super simple experiment, actually. And most of them use the auditory stimuli. So what they do is you just sit in a chair or wherever, and they just give you a train of sounds. And then sometimes there's one sound that is off, and that is the oddball. And you have to count often, just sit there and count the oddballs that appear. So it's a pretty simple experiment to actually perform because you don't have any button press or anything. You just like give somebody a lot of sounds and then they just count them at the end of the experiment. You ask them like how many weird sounds were there, and that's it. So that's very simple to do, and that's why people do it so often. So you have 142 of these experiments. But if you look at it, there are actually other experiments with fewer cases that actually do better than that oddball experiment, which is, of course, a pity because, I mean, if there's other experiments that might be a bit more difficult to do, but actually give a better outcome, then we probably should focus on these things and not just do oddball experiments until forever and ever. So in these experiments, you can, of course, measure these different components. So we have the P100, so the positive going component at 100 milliseconds, P300. And here, once again, you see that P300 is the one that gets measured the most, often together with N200 for the simple reason that this is basically just a thing happening here that N200 goes into P300, so people often measure them together. And the reason why you see that come up so much is, once again, just because it's the thing that people measure in an oddball experiment. But you can also see that there's other things that actually seem to give a better measure of difference between people with MS and controls. So maybe we should actually focus on different paradigms and different components. So the takeaway from this is, well, looking at all these experiments, there definitely are reasons to believe that ERPs are an interesting research venue to assess cognition in MS. When doing that, in terms of the latencies, it seems that the visual experiments actually come out on top. And like I said before, and as you could see in the graph, there's way more auditory experiments than visual experiments, but it actually seems that the visual experiments do better. So maybe we should focus on that. There are all kinds of different paradigms that seem to show potential, but a lot of these paradigms only have a couple of cases, which means that it's very hard to actually say whether that is the case, that they do better than, for example, an oddball experiment. But yeah, the only way we can actually find out is just do them more. So people should probably focus on these other paradigms and then have a look at them. And yeah, so that's basically what we came to. That, well, use visual stimuli and use other paradigms than oddball experiments, because it definitely has potential, but we need to dig deeper into this. Thank you very much.
Hi, well, I'm Ted Mattis. Good afternoon. I'm going to tell you about another visual experiment. Of course, there's a cast of thousands here. So it's a picture of a person who unfortunately has had the top of their head cut off. And you're looking down from above. And you can see some things like their eyeballs here. And this is the optic nerves. And I'll just go ahead. And you get to the chiasm, where the two optic nerves cross over. And this is about where the midbrain is. And the cortex. So this is where the visual thing plugs into the back of your head here, which is what you see with. Now, so the thing to note here, I've got this TV here, and the person is looking at this fairly boring program, which involves green and blue squares. And what you see is that where those stimuli project in the eye, you can see here's the blue from here, here's the green from here, and this is how they flow up to the brain. And if you cut through this pathway at different levels, what you see is that to a certain degree, the parallelism on the screen is preserved on the way up. So that means that testing part of the visual path field out here tests just a part of the visual pathway. And these parts are like spaghetti. There's a whole bunch of tubes. And you can actually, by testing a different part of the visual field, you can test all the different tubes. So you could, in principle, tease out small regions of damage, but you might have to do lots of experiments to do that. You have to test in every single part of the field, right? So can we get away with this? Well, this is what's called a multifocal stimulus. It's kind of hard to look at. And there's some math involved. And what you get is a response to every one of those regions. So this means we can test all the parts of the visual field at the same time, which is much quicker. And here's another experiment. So I've substituted an actual stimulus that we've used here for the TV. And then it's hard to see down here, but these are the responses. Again, one response for each region. And here's what you do. We saw this in Robinson. You put a cap on someone's head like that. But this is a problem because it's a black art. It takes a long time to set up. People don't like it. It messes up their hairdo. Their brains are different. There's all sorts of problems associated with this. So we thought, well, can we come up with something which is non-contact? And the answer is yes, because this is the device at the top here is an earlier prototype. I'd just call your attention to the fact this person is looking in two little holes here, which are also seen here. So this is the device, and that's not going to work. So, and is this going to work? No. Okay, this is supposed to be showing you these blinking stimuli on the two sides. And this is inside the box. And down here, you can just make out the person's eyes. They're looking in the box. And there are two mirrors that direct one eye to one display and the other eye to the other display. And what we record is we use video cameras, which are actually in the shot there, that look through the mirrors in the infrared. And we'll see if this is going to work. Probably not. Okay. So this is supposed to show you the little pupils going like this. And we record that instead of an electrical signal. So we just video what the pupils are doing. So we don't need any wires. And what you get out is kind of like what you get is one response, which is a contraction for each of the stimuli. And this is something that we did with help from some people here and a lot of other people, which is a 10-year follow-up study that's just been published using this instrument. We got back 44 persons out of about 85 who we tested with a much older version of this 10 years ago. And we brought them back and got neurologists to reevaluate their EDSS score, their severity of their disease. And the question was, could the results of the old third generation OFA test, it's called OFA, predict which persons living with MS would progress? And the answer seemed to be yes. So even though it wasn't a very good stimulus that we had at the time, two things were clear. One was that the mean of the three most delayed visual field regions, as recorded in 2009, was quite correlated with the progression of the disease. And then the other thing that we found was there was a significant association between those delays, and the odds of progression. So the risk of progression, in other words, that was significant. And it's hard to read, but it says here, if a person was about 1 standard deviation slower than the rest of the MS crowd, they had about a 2 times greater risk of progressing. If they were 40 milliseconds quicker, they actually had half the risk of progression. That's not bad. So this is a much newer study with the so-called 5th generation stimulus. So the previous one was a 3rd generation. And the stimuli look like this. Of course, these yellow things, they wink on and off in the way that I've shown you before. And we tested 2 different ones, one called W12, that's this one, and one called W20, just because that's the number of regions they've got. W stands for wide field, covers a lot of the visual field. And since both eyes are tested at the same time or concurrently, we can actually measure asymmetries in delay between the 2 eyes. So it turns out that a person might be a bit different than the average person, but what should be the same, like my left hand, right hands, is their left and right eye. So you can actually compare corresponding parts and look for little asymmetries. And that turns out to be a very powerful measure. So what we got here, and I won't be able to show you some of the data, that's fine, is the results of some analysis based on. Can we get rid of that?
Yeah, we can.
Okay, I thought you could, yeah.
Yeah, yeah. So
You
I
just
should
go
I should
there.
have done it sooner.
Okay. Don't pause it.
No.
Uh,
Sorry, hide that one, I
uh,
think. Oh,
No, it's the
no,
other
hide
thing.
the other one,
Yeah,
hide that.
there we go. Oh, this is great. Thank you very much. So let's escape to show, oh, I see. Okay, so what we've got here, we've got 3 rows each for a 4th generation stimulus that I haven't told you about, and 2 5th generation ones, the one that I showed you. And what we've got here is groups of subjects based on their EDSS score. So this split the 44 people into about 3 equal sized groups. So we've got people who are not so affected, a sort of mediumly affected group, and a group that's starting to have some difficulty walking. And what this is what's called an area under a receiver operated curve. So this is a way of measuring how well these tests discriminate the people in each group from normal subjects. And I have to thank Robin, because I didn't know he was going to do this, but he's very nicely introduced the idea of effect size, and that anything over 1 is fantastic. In fact, anything over 2 is called huge. And these are the effect sizes here, and you can see they go up to pretty close to 3. So that's amazing. And then we often in science look at p-values, and we do some kind of a test. So we've done that here, and this upper table is for the W12 stimulus and then the W20. And what we've got here is a delay for the controls. And then what this says is that people in this group are 7 milliseconds slower, in this group 17 milliseconds slower, in this group 30 milliseconds slower. And I'll call your attention to the p-values over here. And for scientists in the crowd, probably they've never seen 4 times 10 to the minus 17 in their life. But what I can tell you is that's a consequence of this very large effect size. So if you don't have an effect size of 2, forget it. You do not have a diagnostic test, sorry. And the message here is that this older test took 7 minutes to measure 2 hours, and these new ones only take 82 seconds. So the conclusions is that OFA may provide a rapid and convenient method of monitoring and predicting MS progression. And it may provide, for example, new clinical endpoints for new therapeutics, because being more accurate, you might be able to get to the answer quicker. It will be sold internationally next year, so it is readily available. And a more portable unit is coming. And in fact, both the desktop unit that I showed you and the portable can do telemedicine. So it could be used in remote areas of Australia, for example, where you might not have easy access to, say, an MRI scanner. And certainly the results will probably complement the results of MRI scanning. That's it. Thanks for listening. If you want to get in touch, please go ahead.
Okay, so I thought I'd take the opportunity to just summarize what you just heard. So the last presenters all in this session are part of Ohio, so our health in our hands, and you heard a lot about this today already. So we just heard talks about or coming from these different bits of Ohio. So for example, I'm really struggling with this thing here. We heard Robin, who is sitting here in program 2 with the big data. We heard Ted on his OFA sitting here in the biomarker discovery and monitoring devices field, and of course Jane from the health experience, as well as Katrina. So, so this is how we organized, and just to give you an idea, this is the current active members of Ohio. So the colors indicate if there are PhD student, postdocs, principal investigators, so professors or group leaders. And what I wanted to say is, so there is a lot going on in the Ohio space, and that was just a snapshot of what's happening. Yes, so, but my task today is to tell you a little bit more about what's next in MS research in Ohio in the next year or two. And I would like to focus on one thing we are currently developing, and this is to use multidimensional biomarkers to disentangle, quantify, and understand the components of fatigue in MS. So you've heard a lot about fatigue from Rowan, from Chiara, from Katrina. I think everybody mentioned fatigue, and we know that this is one of the biggest issue we get reported on for people living with MS. And so we thought, how can we as Ohio, as our interdisciplinary team, help with this? And we thought basically there's two sides of the problem. And I really liked Chiara's story in here because it really emphasized this two-sided problem. So we have the problem of the person with fatigue. So the need to communicate what kind of fatigue they have, the need to communicate how it affects them and being heard, but also the problem on the treating clinician side to be able to assess it in a sensible way and to like classify and verify the fatigue. So how do we get a number to something we can only experience ourselves? And so our aim is now to identify and characterize these objective and subjective measure of fatigue. So what do I mean with this? So the subjective measures is basically what you report to us. So what you report in questionnaires, what do you report in interviews? We tried a couple of ways to to depict the fatigue you're experiencing. And then of course the measurable things. On what medication are you? What's your sleep pattern? How is maybe your fatigue reflected in your blood sample? Do we see some inflammatory markers in there which might be related to it? And these things we want to bring together to help both the person with fatigue as well as the treating clinician to actually understand it better. So the how is basically exactly what I just said. So we have both sides, and in the vein of Ohio, trying to bring together this objective lived experience with whatever we can measure. And so for the measuring part, we will use blood analysis, but also phenotypical assessments. So we have in Ohio, for example, Hannah developed this dexterity app, like finger tapping app, where we can look at like upper limb function. But we're also working with the balance plate, and of course, Ted's OFA might give us the necessary information to get a better picture of what fatigue actually means for the individual. It's a big task. We're developing it, and I'm calling on all of you to help us by participating in our studies, joining the MS Ohio cohort, and also maybe if you have time and you're willing to work with us in working groups, to figure out how we can measure your objective experience better. Yes, so this is not all. We have a couple of priorities in Ohio. As you heard, we'll be working in all different kinds of areas. And so there is the fatigue sub-study I just mentioned. Then also, as Joe alluded, we now have enough samples in our cohort study to actually do the first deep dive into the data. So this is coming up in the next couple of weeks and months. We did make some progress in developing new sensors of blood-borne biomarkers, for example, NFL, the neurofilament light chains. There's a poster outside from Artie. Artie sitting over here, can you wave your hand? So if it's a tiny poster, so if you have any questions to the tiny poster, find Artie. And you just heard what Ted is planning with the U of A, that it's going to be rolled out, and we also going to bring one into the sun, into Sydney, to get this kind of data from that part of our cohort as well. Yes, and then very excitingly, so I've heard the question, so how can we contribute? How can we participate in the studies? And that often the ACT is excluded from studies. So one thing we thought we can actually bring this closer to the ACT community is by linking ourselves better into existing and emerging new MS consortiums, like research efforts. And one of them is this collaborative open coast-to-coast Australian multiple sclerosis study, OCAMS. And I'm very happy to tell you that the second speaker after the lunch break is Professor Trifan from Sydney, who is leading this new study, and he will tell us what they're planning and how it is comprised and how we all can participate. And so on that note, I just wanted to say, even though we are in the ACT often restricted in how we can participate with like having to travel to Melbourne or Sydney, there's other ways. And I think what Jane was describing and also what Katrina was describing in their talks, these are ways you can participate and contribute to research. So it's not only about like giving your sample or something, it's about your input, your experience, your information, which really helps us develop our research. And with that, I would like to thank all the little blobs, the whole Ohio team, and of course, all of you for coming, and everybody who has been involved in the studies and the workshops and all these efforts we've done over the last 4 years. And with this, oh yeah, we have one more video, which between us and the.
Thank you, Anne.
I'm involved in MS research as a way to take back control of my journey with MS. I've found that there's a lot of uncertainty and a lot of loss of control when you do get diagnosed with MS and you live with MS. So this was one way for me to take back that little bit of control, and also it's a way for me to feel like I am contributing to finding a solution to the problem that is MS. So those are the two main reasons.
So I'm doing my PhD at the moment, so looking into better ways that we can deliver MS therapies. I actually came in with very little background on MS. I knew I kind of wanted to work in the field of immunology, but I actually didn't really know much about MS or really know many people with MS. So I kind of, first came to meet my supervisor in the lab and hear a little bit about the research they were doing. And I think what drew me to it was, I guess, there's so much that we don't know because MS is, of course, so complex, and that the lab is I guess, doing research to improve our knowledge of a little corner of, I guess, MS immunology. But hopefully one day, you know, knowing more about that little bit of such a complex picture will add to our overall understanding of MS and actually translate to improving, you know, quality of life and prognosis with MS.
I've got involved in MS research largely because my wife has MS and therefore I have a keen interest in doing everything I can to assist researchers working in the field, but also because now that I'm semi-retired, I feel I ought to be doing things to give back to society. I've had a terrific career and this is one of the things I can do just to make a contribution.
I'm involved in MS research as a Masters of Philosophy student with the Bristol Lab. I specialize in deep learning and artificial intelligence and the application of that in hopefully aiding diagnostics for multiple sclerosis.
Well, as you know, I'm a person with MS. I was diagnosed nearly 30 years ago now, so I naturally have an interest in research and its associated findings, as I stand to benefit personally. I became involved with MS research and the higher team because I wanted to contribute and help others if I could. I believe that people with MS can bring a lot to the research table, particularly through sharing our experiences with researchers. MS is such a variable disease, so it's important that researchers are provided with the opportunity to understand our differing experiences and perspectives. I've found being involved with MS research has given me a voice, and it's been empowering. For example, as a member of the team, I have the opportunity to review and contribute to research papers. We also get to provide input on future research projects, and that's great.
MS research is important to me because I'm a person who lives with MS. From a personal perspective, trying to find ways to improve life outcomes for people living with MS is obviously very important to me. And the only way we can find treatments and better ways to live with MS is through research.
For me, with the kind of research I'm doing, looking kind of directly at delivering MS disease-modifying therapies, what I really like and what's important to me is that it's something that's, I can clearly see where that might make a difference to people's lives. So hopefully the work I am doing will one day directly translate to, you know, improved quality of life or safer therapies or just better outcomes in terms of MS treatment. I think with MS research more generally, the fact is that there's so much that's completely unknown about MS. The kind of research we do, chipping away at looking at those unknowns, has the real capacity one day to actually translate to differences in how people live their lives. And I think that's really important. And it's what everyone doing medical research is trying to do.
MS research holds huge potential to make a difference to the lives of a lot of people who really are in both a difficult position, but also an ominous position as to what the future of their disease holds. And I think the opportunity to be a contributor to something that can fundamentally change the progression of MS and can perhaps fundamentally lead to a reversal or ultimately a cure of MS is a really exciting opportunity to do something that's worth doing. It's interesting to note how much progress has been made in the treatment of MS over the last 10, 15 years. And if the same amount of progress happens over the next 10 to 15 years, then we'll see a really exciting change to the future for people who are unfortunate enough to be living with MS.
MS research is important to me because it's an under-recognized and underdiagnosed disease. And so there's a lot of work to be done in this area that can really help quite a substantial portion of the population, even through just earlier diagnosis and earlier treatment regimes.
As we know, there's currently no cure for MS. Obviously, finding a cure is extremely important. In the meantime, however, I think it's important that research is undertaken to find ways to help people with MS live better with the disease. This is often because MS is described as an invisible disease. It is often difficult to measure and show disease progression, and it can be hard for others, i.e. friends, family, carers and employers, to understand what we're experiencing. So MS research improves our knowledge base. The better educated we are about this disease, the better armed we are to learn to live with it. And I like to think the more likely others in the community are able to understand our needs and concerns. It can lead to the provision of better services. Also, good quality MS research and the associated recommendations can help provide a sense of assurance to people like me. And I think this is essential when you have a disease that has so much uncertainty attached to it.
Thanks to all the people who contributed to the video. Thank you to Ali Weatherall, who did all the editing as well. And you can imagine that's a tedious and long-winded task, but thank you to Ali and Toby for that.
Our first speaker is Jessica Lovell. She's a very experienced technician with 15 years of practice, and recently in the Anne Bruce's lab. She was awarded a Bachelor of Science in Biology from Macquarie University a couple of years ago, and she will today talk on improving delivery of MS treatments.
Cool. Sorry, just give me 2 seconds to finish setting this up.
Okay, sorry. Well, I'll do a little dance or something to distract the audience.
No, we should be good. Cool. So I will be presenting work done in our lab with Anna Brucelar. And this is work carried out by our brilliant PhD student, Nadia, who you may have seen speak in the participant video earlier. So a little bit about me, other than what Nick said. I am Anna's jack of all trades. So I would also like to extend my thanks to those who participate in the Ohio blood draws. I am the one that carries out all the processing analysis behind the scenes. And also welcome to anyone who decides to participate after today. So as Nick said, I'm going to be talking about improving delivery of MS treatments. And so let's get into it, I guess. So as most of you in this room will be aware anyway, in the last 30 years, there's been quite a range of treatments that have come out for MS therapy. Unfortunately, though, these are all delivered systemically and they're not specific to sites of information. And as a lot of you here would also be aware, they carry a lot of side effects, and some of them can be quite detrimental. So we have a really unique opportunity here at the John Curtin at the moment. We have a company on campus called Lipotech who are developing lipid nanoparticles. And so basically they're just fat blobs that have proteins on them. But the great thing about them is that you can package things in them to transport. So you may be aware recently with the COVID vaccines that the mRNA vaccine was delivered in these similar nanoparticles. So it's already in use and development. The great thing about these liposomes is that we know that they traffic to sites of inflammation or sites of leaky vessels. And why is this important to us? Is that if you look here at this MRI, most of you have probably seen an MRI before. In the red box is a site of a lesion in an MS brain. And so when you add a contrast dye to the system of a person, where the leaky vessels are, that's why we get the image of the lesion, because all of that contrast dye will accumulate in that spot. And so that's great for us with these liposomes. So I'm going to sidestep a little bit and just go, multiple sclerosis, we all know what it is. In terms of, we know that there's a lot of genetic, environmental, modifiable risk factors that go into causing an immune response that attacks the myelin sheath on the neuron. And so obviously this is really hard to study. You've all heard experiences where everyone's MS is different. And so it's not easily studied. However, we do have a mouse model that has been used for decades for a lot of the therapeutic analysis called the experimental autoimmune encephalomyelitis model. It is a mouthful, or EAE. So basically what this is we take a myelin peptide, an adjuvant and an immune trigger, and we target immune systems specifically to cause neuroinflammation. And we can score this clinically, and the scoring system is not unlike the EDSS, but it's much more simplified. And so we have a clinical score of 0, which is this mouse up here. And so they will have a normal gait. All of their reflexes will be perfectly normal for a mouse. And then we get to progressive paralysis, and we get to a score of 3 where they exhibit hind limb paralysis, which wouldn't be unlike anyone in a wheelchair or potentially even bedbound. EAE is a very replicatable model in the sense that it always has 3 main phases. So we have a pretty preclinical phase of EAE. We have an acute phase where we see those symptoms coming up. And then we have a chronic phase where those symptoms slightly plateau into a steady state of paralysis, I guess you could call it. So that's a little bit about the model. But we wanted to, going back to the liposomes now, we wanted to determine if they would accumulate in the CNS during neuroinflammation. As you know, we want these drugs to be where they need to be, or in this terms, the liposomes. So we induced these mice with the EAE model, and we gave Lipotech nicely made us some liposomes that had a fluorescent dye encased on the outside of them. And we gave the mice these liposomes 5 days before analysis, meaning that the liposomes had 5 days to circulate through the system, or 2 days before analysis, 2 days circulating through the system. And so we looked at imaging under what's called an IVUS, and basically it's just, it measures fluorescence in an organ. And so you can see we use the spleen first, as we know this is a site where liposomes traffic to, and it's also an immune organ. But you can see here in the uninjected control, there is no signal. And so what I mean by signal is you see how in the healthy controls, we see this red, they become red. So that is the fluorescence indicator from the machine. It tells us how bright they are. And so unsurprisingly, we also saw this in EAE. However, all good and well, we can see the liposomes. What does this mean in terms of neuroinflammation? So again, we looked at in the brains of the same animals, and we looked at an uninjected control. We don't see a signal. Importantly, in our healthy controls, where you shouldn't see any signs of leaky vessels or inflammation in the brain, we don't see a signal either. But very excitingly, we see a slight signal at the 2 days worth of liposome circulation. But more importantly, we see an accumulation. So after 5 days, we see much more signal in the brains of these mice. And so this could be very important in targeting neuroinflammation. And so we wanted to, as proof of principle, work out whether we could effectively target neuroinflammation with any of the drugs. So we happened to choose mitoxantrone. It is an anti-tumor drug that was repurposed through EAE studies and is quite effective in MS. However, it comes with a really serious side effect of cardiotoxicity. So people can only be on it for a short amount of time because it's very dose dependent. And so we hope to minimize this by packaging the drug in a liposome. And so again, with Lipotech's help, they packaged mitoxantrone into these liposomes. And we again performed EAE. So we took, as I said before, we took mice, injected them with the adjuvants, and created this immune response. And then we either proceeded to inject them once a week with a very low dose of a freely delivered MTX or mitoxantrone, or a liposomal bound mitoxantrone. And these are extremely low doses because we didn't want to cause cardiotoxicity in these mice. We wanted to see what the effects would be. And so when you have a group that's essentially untreated by only giving them a saline injection, we get a normal scoring system. Interestingly, at a very low dose of mitoxantrone, we don't see any significant changes in their scoring either. However, excitingly, very excited, at once a week dosing at a very low dose, we see no disease curve in our LMCX treated mice. And so, you know, this could be a number of reasons, which we're still analyzing. But one of the things we wanted to look at aside from this was what immune cells are affected by this treatment regime. And so we looked at the normal players of immune responses, so your leukocytes, which are just normal total immune cells. And we saw a decrease in the LMCX treated mice. And then we wanted to sort of tease out, was this a B cell response? Was this a T cell response, being a T cell lab? And so we saw there was no change in the B cell numbers in these mice. However, when you look at T cell subsets that have been heavily attributed to progression of EAE and also in MS, so these IL-17 producing CD4 T cells and these GM-CSF producing CD4 T cells, we see a significant reduction in both subsets, which could be why we don't get the EAE response, which is amazing, really. And so just sort of to summarize everything I've just sort of shown you today. So we do know that our liposomes accumulate into the sites of inflammation, and especially in the CNS. And we have shown that the mitoxantrone in liposomes is effective at really, really significantly lower doses than what would normally be delivered. And obviously the significance of this is like potential therapeutic opportunities. We can have more targeted deliveries to sites of inflammation rather than systemically giving you these drugs. But also hopefully it might carry out in other compounds where we can use much lower concentrations of them as well. And hopefully to reduce the side effects ultimately. And with that, I'd like to thank a few people. So Anna and Nadia, who Anna, we wouldn't have a lab, but Nadia, who did most of this work. And then also MSRA for funding this project, Lipotech for making our liposomes, and my job wouldn't exist without all the mice that were involved in this study. So I'd like to thank them as well.
Wonderful. Thank you very much, Jessica. We've got time for some questions. You know, some in the audience. While you're thinking about it, I've got one, and this is how quickly can this delivery system be implemented at scale? Producing liposome, is it something that is intricate and difficult and will take a lot of adjustment to producing large quantity, or is it something that we can foresee is ready for use if we find the right drugs?
Yeah, so the liposomes themselves, I mean, there's a lot of companies working on liposomes at the moment. The ones we specifically are using, I think they've had quite good production of them. I mean, we know that there's large scale opportunities because they were used in the mRNA vaccines for COVID. So there's obviously a way to expand. I think Lipotech at the moment are getting larger. They are working with a lot more groups within at least ANU and I think worldwide now. I think they've got a couple of partners elsewhere. And so I don't see a problem in mass producing them. I think one of the things we need to think about is what therapies to think about using. Because obviously you don't want to just chuck every therapy in and hope for the best. You need to make sure that these are the right ones to package. Because if they're not going to work in the packaging, then they're not going to work. Yeah.
Following on from that question, are there certain compounds that can't be put into a liposome? Like, can you put monoclonal antibodies in? Can it be anything, or do we know?
So
that?
I don't know 100% because I don't work for Lipotech, but from what I understand from what they've told us, there isn't a limitation yet that they've found. I think the main limitation is size, because these are nanoparticles, obviously. But I also think it's whether or not those compounds will then work outside of the lipid particle. So I think, again, it's not my area of expertise, but that's, yeah.
Other questions?
Are you saying that the current drugs that they're using to modify can be delivered using this methodology?
Yes.
And have a more direct impact in reducing the symptoms?
So that, yeah, so that's currently the theory. We obviously have only tested one drug. We've tested this one.
Yeah.
It doesn't account for side effects either. We're hoping that using smaller amounts directly targeted, because they're going to these sites of inflammation, will reduce side effects. And we're also hoping that because they're not going systemically and getting caught up in other tissues and cells and et cetera, that you're trafficking more of the compound to where it needs to be. So maybe it will work better. But again, this is all theory and we haven't tested it all fully yet. Yes.
Possibly a bit of an unfair question.
Of course,
We
Tree.
talked about the 3 phases, one of which is the chronic PAE phase.
Yep.
I'm just curious if you have plans to see if these particles will make it have an impact on the chronic phase in mice with established disease.
Yeah, so we do have opportunity to do a relapsing remitting model as well, which we could potentially use these liposomes in. We haven't got it fully established yet, so that's ongoing work. And I think we have taken these mice out quite far from end of treatment as well, and haven't seen the recurrence, like a new phase of EA. So I mean, there's potential there to look at targeting the different stages, but at the moment it's still early work and we're still doing it from the beginning. Yeah.
Thank you very much. So our next speaker is Professor Troy Fan. Professor Fan is an NHMRC Senior Research Fellow and practicing clinical scientist. He co-leads the Precision Immunology Program and co-directs a center at the Garvan Institute, which has the most challenging acronym I have seen in recent times. I had to look it up, called the Australian Cancer Research Foundation Centre for Individual Imaging of Niches for Cancer Immune Therapy. All right, now we're ready to have a break. Professor Fan is a senior faculty and contributor to the leadership and executive at the Garvan Institute. He is one of the pioneers and early adopters of innovative cutting-edge technologies, including single-cell genomics to solve long-standing clinical and biological questions for which he was awarded the NANSTOR Eureka Prize in 2014. I will not even attempt to describe the nature of his research, as I'm likely to mess it up, but he will enlighten us in a second on this topic in today's talk on applying Occam's molecular razor to study the relationship between Epstein-Barr virus and MS. Over to you.
Thanks so much, Nick. I'm really embarrassed now because I think that's a lot to live up to. So I really want to first start by thanking the opportunity to come and speak to you today. This is a bit of an unusual talk for me to give, I guess, because normally we talk about research that we've already done. What I want to talk to you about today is research that we want to do, and maybe some of the inspiration behind that, and some of the motivation, because I think for many, so I'll backtrack a little bit. So as Nick mentioned, I'm a clinician, I'm a clinical immunologist, but I'm also a scientist. And in the clinical immunology space for many decades now, we've been confronted with patients with chronic diseases that we didn't really understand, didn't really know how to treat. And we really struggled with being able to being able to individualize the treatment so that we can have, a positive effect without the side effects. And I feel like that's kind of like where the MS field is as well. What's really changed and been really inspiring in the last couple of years, particularly, has been the fact that now science is beginning to show us the way with the development of new technology, some of which I'll speak to today, particularly some of the single-cell genomic technologies, which is then going to give us the opportunity to start understanding what it is that's different between us as individuals and how those differences shape the way our immune system responds to the environment, and in some cases, how that response can lead to pathology. So being, as Nick mentioned, a big fan of acronyms, I want to talk to you about this program that we're really excited about, which has really been inspired largely by Jennifer Massey, who's going to be talking to you next. And so Occam's razor, some of you will know, is all about parsimony, about reducing things to, like the simplest solutions are probably often the best solutions. So OCCMS actually stands for the Open Coast to Coast Australian Multiple Sclerosis Consortium. And I'm also a big fan of wordplay. So if you put a space between the A and the M, it's also the OCCA MS Consortium. So what we want to talk about today is actually some work that's really crystallized thinking for many decades, and which is the idea that maybe in MS, the problem is a really dysregulated immune response to an environmental pathogen, in this case, the Epstein-Barr virus. So this really, let me see if I can work this. I have a PhD, but I don't know how to use a slide. Okay, I think we'll, okay, all right. So for many years now, people have been thinking that there's MS sitting behind it might be some sort of virus. And the culprit has been proposed for many years to be the EBV virus. And what happened earlier this year was that in a really remarkable study that I think could only ever be done in the United States, they tracked armed forces personnel, 10 million of them. So these are, they have serial blood, they have annual physicals and blood samples taken every time. They tracked 10 million US armed forces personnel over 20 years. And in that period of time, they were able to identify 955 individuals who developed the onset of MS for the first time. And then by going back and looking in the collected serum, they were able to show that in the time before they developed MS, they seroconverted. So they went from EBV negative to EBV positive. And that really provided very strong, compelling evidence that maybe there's something about this virus that causes a very abnormal immune response. And so the real challenge for us then is to understand that, because if we think about it, EBV infects more than 90% of healthy adults. So that's 9 in 10 of us in this room will have a positive blood test saying we've been exposed to EBV. But MS only afflicts less than 1 in 1,000. So there's a big discrepancy. If it's caused by EBV, what's that middle step in between? And that's what OCCMS is about. We want to know what it is in between that leads to the development of MS. So one of the very powerful theories is this idea of molecular mimicry. And molecular mimicry basically says that the immune response to some component of the virus recognizes then by mistake some part of the body, in this case, some part of the myelin sheath that gets attacked in MS. So this paper came out not long afterwards, showing that in people with MS, you can identify in the CSF, so that the fluid that the brain is bathed in, you can find B cells, and that these B cells have evidence that they're being activated and they're making antibodies. And these antibodies, when they cloned the B cell receptor and expressed it, they found that not only was the antibody reacting against a part of the virus called EPNA1, that antibody could cross-react with a part of the CNS called glican. So there's this idea that maybe in the susceptible individuals, you're making an antibody, an immune response to the virus that ends up attacking yourself or parts of your brain. Of course, there are many other theories about how EBV might impact on MS. And I guess being in Australia, one of the more powerful ideas has come from Brisbane, from Michael Pender's, known as the Pender hypothesis. And it's the idea that somehow in individuals who are susceptible, they can't control the EBV virus. And so the virus infects B cells that are self-reactive. And normally those self-reactive B cells will be controlled by the immune system. But because these individuals can't do that, then those self-reactive B cells get transformed by the virus and then somehow become activated to make antibodies against parts of the brain. And that's the oligoclonal bands that we see. So how are we going to solve this? So as I mentioned, these kinds of discoveries have been really exciting, but I think really to really solve a problem as big as MS, I think what we need is really a change in the way we approach it. I think part of the problem for a long time, definitely speaking from the clinical immunology space, is that too often we have, the clinicians siloed in the hospitals and the scientists siloed, in the universities. What we really need to do is to have a mechanism where we can bring the clinicians and the scientists into the same room. And not only do we need to do that, we need to bring people into the room who don't normally work on MS, people who work in other spaces. So we really need an interdisciplinary approach. So that's what this Occam's consortium that I want to tell you about today, that's what we're trying to do. So we are hopefully bringing together MS researchers, not just in Sydney and Canberra, but also in Perth, in Melbourne, in Tasmania, and hopefully, soon across the whole of Australia. But we're also bringing experts from overseas. We're bringing experts from Stanford in the United States, from the University of Birmingham. We have the premier expert in the world on EBV, and then also from the University of Münster in Germany. So our approach is a really open, collaborative approach. And the idea is to challenge each other to come up with innovative ways of thinking and innovative ways of solving this problem. And so this is a very complicated slide, but the whole point of this slide I wanted to tell you is that essentially what we're trying to capture here is the life cycle of the EBV virus. So it comes in and it infects the epithelial cells in our tonsils. And from the epithelial cells, our B cells get infected. And these B cells then migrate through the circulation. They drain to the draining lymph nodes. So these are the glands in your neck. And then somehow the pathogenic B cells, the B cells that attack the central nervous system, they traffic to the brain through the lymphatic system. And somewhere along the way, something goes wrong, and a B cell that shouldn't be alive is alive, and a B cell that shouldn't be making antibodies is somehow making antibodies that's attacking the central nervous system. And so, what I've listed there, essentially, some of the ideas that we want to challenge through our study. We want to find out what is it about host immunity, host genetics, about the T cells and the B cells themselves. What is it that's different from one individual to the next that makes the immune response different and thereby, predisposes you to developing MS. And the way we're going to do that, essentially, what we want to do is recruit persons living with MS, but as well as that, healthy controls. And Occam's is really, well, I think anyway, a step change in the way we approach clinical research, not just MS research. And that is that quite often in Australia, not only do we have silos between scientists and clinicians, we also have silos between different institutions, and everybody has their own, cohorts that they want to keep control of. What we're trying to do is have a federated system where everyone still retains control, but are able to come together and work together. So what we want to do then is to bring all these cohorts, unite them, and then through the power of having large numbers, we can do large-scale science and use some of these genomic technologies. We want to create a biobank so we have an ongoing resource, not just for the study that we want to do in the next few years, but for studies that we might want to do in 10 years' time, in 20 years' time. And what we want to do then is to start bringing, all these disciplines together, start bridging the knowledge gaps, and then, engage so that we can actually do things that are going to be meaningful and helpful for people living with MS. So we've got 3 arms to the study. The first arm uses a cohort that Jennifer's already established at St Vincent's Hospital, but also this large cohort of healthy controls that's already established, the 1K cohort. And what we want to do there is take the PBMCs, transform them with EBV, make these lymphoblastoid cell lines, and then start using all these single cell genomic technologies to start interrogating them. So we want to do single cell RNA sequencing, but not just that. In the same cell, we want to do single cell chromatin accessibility studies so that we can tell in an individual cell what genes has been expressed and then what gene controls are then determining that gene expression. So the whole idea is then we can take that information and then overlay on it work that's been done for many years through things like OSGene and the International MS Genetics Consortium, where they've done big, large-scale genome-wide association studies. So if we overlay all these layers of information, the idea then would be that we'd be able to work out what it is that's variable from one individual to the next, and then within that individual from one cell to the next, to understand what's sitting behind this susceptibility. And so the second part is to track the B cells through these different compartments that they travel through, where we know the virus is active. And what we really now want to do in this part of the study is to understand these B cells, for example, in the brain that's making antibodies that's attacking the central nervous system. Are these B cells infected with EBV? And is the EBV altering their genetic makeup in such a way that it's making them autoreactive, or allowing an autoreactive cell to survive? So those sorts of studies, I think, are going to be really informative, and I think definitely both the studies I'm describing will be, very much the first of its type. And then the final part we want to do is then bring all this information together. So from the first two studies, and then from clinical information, we want to extract all the data that's generated, and then using machine learning, work out, what are the features that can help tell whether an individual is at risk of developing MS or not. And so the whole idea then is that we develop a risk score. And what we're really hoping then is with this risk score, we can develop a very simple blood test that can tell you if you're a first degree relative of someone with MS, what your risk might be. Now, the dream here is, so some of you may have heard on Friday in the United States, the FDA, which is, I think, the Federal Drug Authority. Anyway, it's the FDA in the United States licensed a new biologic, a monoclonal antibody, again, that targets CD3. So it depletes T cells. And they licensed it for primary prevention of an autoimmune disease of type 1 diabetes. This is our dream. We want to get to a place where we will have a test that can tell who's got risk of developing MS, and then we can step in and do a trial to see if we can prevent them from going on to develop MS. We basically want to be at where they were at on Friday with this new drug, which was shown in a clinical trial a couple of years ago to delay the onset of type 1 diabetes, but only 22 months, right? So they're not cured. These individuals will still get on to develop type 1 diabetes, but that 22-month delay can have a significant impact. For example, if the onset is, instead of in adolescence, it's early adulthood, that gives an opportunity for the pancreas to grow, gives an opportunity for, also maturity to, in terms of individuals' emotional state and ability to cope with chronic disease. So what we're really hoping is that even if we can come up with a drug that doesn't completely prevent it, but just delays it, just being able to delay the disability, I think that's like one of the biggest, most urgent unmet needs in this space. The fact that we're looking at a disease that affects young people, that's going to cause chronic disability. So that's kind of like our end game. And I think I've taken up too much time, so I'm going to stop there, and thank you for your attention.
Fantastic talk. Thank you very much, Ray. We have time for questions. Please.
Who gets the Epstein-Barr virus? And is it common in the population? Why do some people react differently?
Yeah, so the Epstein-Barr virus is ubiquitous. It's also known as the kissing disease. And over 90% of people, when exposed, show evidence that they've had it by having a positive blood test for it. So it's not something that you can stop people transmitting unless they go and live, yeah, and live in a hermit life.
That's common.
Yeah.
Given how common it is, I was tested with my diagnosis for the Epstein-Barr virus. But if 90% of the population is exposed to it, why virus is super?
Yeah, that's a really great question. Where we want to go with it is not so much to test for the Epstein-Barr virus, but test for a biomarker that tells us that if you're exposed to the Epstein-Barr virus, your immune system is going to, get it wrong and start attacking your nervous system instead of the virus.
So the request we got tests for newly diagnosed people is information about it.
Yeah, I guess so. It's not, what would be very unusual. So in that study that I mentioned at the beginning, where they tracked 10 million US Armed Forces personnel, 955 individuals developed MS in the 20-year period, and only one of that 955 was negative for the Epstein-Barr virus. So you can still get it if you don't have, but the debate is whether the blood test is perfect, right? So it may be that that person was exposed, but you never developed the antibodies. So there's a lot of subtlety still, and I guess quite often when we're in a space, now I'm talking with my doctor hat on, where the science isn't really settled and we're still finding our way, sometimes we do test because we just want to be sure that we don't miss an opportunity down the track if new information becomes available. Another question?
I also have a question, and that is, right, putting my epidemiologist hat on, so there is the approach you're proposing in trying to find out what the mechanism is and then target it with drug is obviously a very precise one. Another possibility is to try and look before as to the transition between having versus not having the Epstein-Barr virus or converting. And I can see that this is problematic because you have to catch people just at the right time. But do you think that there might be something viable to do there on an epidemiological large-scale perspective where people are, I don't know, children or the most at-risk group is screened every year?
I think that's a really, really good question. And our ambition, I guess this is our starting point, but our ambition with Occam's is to create an environment in which other people can come in with, like, for example, such as yourself, with questions like that, and we can provide the framework. In this case, the sort of thing that you're proposing, which is kind of like a longitudinal study, maybe your first degree relatives who we know will be at higher risk, particularly if they have certain HLA haplotypes, and then tracking them longitudinally over, a long period of time, especially around that critical adolescent phase when they start, getting exposed to the Epstein-Barr virus. So we can see that would be an incredibly powerful study, and definitely one that, it would also be very expensive, but yeah, but I think that would be really awesome. And yeah, and absolutely, part of our thinking behind this is to create a national platform for people to come along and say, look, this is interesting, or that is interesting. Is there a potential to do something like this?
And a very quick, we've got another question there.
Sure. Just to explain why this is so complicated. So I worked on EBV in the past on the virologists, but also heavens. So So EDV on US so it's for everybody's considered, no one's got it, right? But actually it's not true. If you look at the general population stuff, 100%, if you look at a room of people with MS, it's very close to 100%. And that's why we think this is the again.
But it is possible is now taking negative.
I'm very, very unlikely. Once you've got it, it's from a group of viruses, but once you get it, your body doesn't get rid of it. It just hangs around. And this one hangs around in a certain type of your white blood cells. The thing is that people get it at 6 times in their life. The majority of people get EDV when they're very, very small children and they have no idea. So either their numbers is screaming it to them or whatever, so they're going to get it at that age when they just start with it. But that's most people. Some people don't get it, right? And they avoid that slowly stage. That's not what I want. But then they kiss someone when they start doing that kind of thing. Usually just before you fall themselves. Very inconvenient, right? And if you meet that virus when you're older, that's when you have quite a high risk of getting around to it. So these sort of two different groups of people. The very cool study that Tree is talking about, what they did that got so much better is they found people who were still EDV negative at the start of the trial, right? And then followed them and asked, do they get EDV? And then do they get MS? And so what they found is that people that in their study they could see got EDV and most of them got went to feeling, then those people went on to get MS. So that's a really powerful study. But it says more about whether perhaps MS is related to his experience of being EDV in his life, right? And that may be getting into MS. And you know, I know I got it in the first main trial. So in my mind, there's still quite a lot of doubt about whether my MS happened with all, right? Because of when I applied it. But I just wanted to say those things because it's not as clean as sometimes you see in the media, where it's like you get EDV, EDV is essential, and you know, to go on to MS, and what we need to find is semantic thing that links those two things together. And it may well be that there's a semantic thing. And I think that's the point of the study he's talking about. We want to know what's going on that's finding people present with their symptoms to MS. And can we tie that back to anything like an immune response going on?
Are you saying that people can get it as and still develop MS?
Of course.
Whereas
Remember,
this study,
everyone's got it. Everyone's got it.
so this study proved that you got it as an adult.
The one that was studied that everyone's talked about is much more about people who've got away from life. Because you can't go back and find out when people got it. So it's just too hard. And people have extrapolated to say Epstein-Barr virus is off. I think that's where it's perhaps really simplistic. So the study here is really about saying when people present at the start of their illness, so as close as we can get to when things start going wrong, can we find something that links that back to a wrong response? In fact, previously say it, but the whole point of the study is to be quite open-minded because there's other viruses too that people have said might be for them. So you know, the idea is here, even if we can't fight that, people are actually so that it doesn't seem to do anything. We might still be able to find this evidence of the immune system not being quite right, but we can then use, you know, going forward.
Good question.
Even to the amounts.
I think what you're saying, David, is that there's no causal pathway identified. This is the safety, and I think it's really important to point that out. It's not causation, it's just the safety. Right.
Very important points to make, and thanks for sort of communicating this very clearly. I think we'll move to our last talk, and afterwards we'll probably have time for more questions. Thanks, Tree. So our next speaker is Professor Jennifer Massey. Professor Massey is staff specialist neurologist with expertise in MS at St Vincent's Hospital in Sydney, as well as an MS Australia postdoctoral research fellow at the Kinghorn Cancer Centre and St Vincent's Centre for Applied Medical Research. Prof. Massey also contributes as senior lecturer in the School of Medicine and Health at the University of New South Wales. Particularly relevant to our audience today, she's lead neurologist in one of the largest international clinical trials of autologous hematopoietic stem cell transplant for MS, which is the topic of her talk today on autologous hematopoietic. I'm sure they did it on purpose. Okay, stem cell transplant. Who, what, where, and why?
Thanks, Mitch. Thanks. I'm not a professor. I'd love to be, but I just feel like I need to get that out in the open now. Just a jobbing clinician. I've been involved in the program that's been running out of St Vincent's since 2010. I became involved in 2017. And, you know, I use this acronym and often it's abbreviated to transplantation or stem cells. And there's obviously a lot of, I mean, David touched on this before, misrepresentation in the media. And so this is a really great example of a lot of, I guess, mixed reporting about what the treatment involves, what the risks involve, and what the expected outcome involves. And so this kind of who, what, when, where, why is a bit of an overview of that. And then obviously love to chat and have people ask any questions at the end. So hopefully, yeah. So in terms of who, so it's quite funny. So we just said about issues with the media. So often when you see this reported, people will be saying this novel or, you know, experimental therapy, but actually this treatment's been used for MS, for autoimmune disease, actually dating back to the early 90s. So, you know, we had our first disease modifying therapies in MS, the interferons, back in 1991. And so this is actually the second treatment that was kind of used in a clinical trial setting for MS. But you can see that even bearing that in mind, over the last, you know, 3 decades, there has been an increase in the incidence of the number of people who are having this treatment globally. So this data is from the European Bone Marrow Transplant Registry, and most countries who run clinical trials of hematopoietic stem cell transplantation report their data to this European registry. So it's kind of the best metric that we have globally of seeing the number of people having this and the indications for it. So is there a pointer? Okay, I'll just use my finger. So you can see, obviously, there are certain countries where this is used more frequently. And Australia actually probably contributes quite a large volume of patients, which is predominantly driven from our centre at St Vincent's. In terms of how this treatment is being used in MS, so obviously early on, the treatment was sort of considered like a last attempt therapy. So it was predominantly used in patients with progressive MS. And as it's evolved over the last 2 decades, you can see increasingly it's being employed in the setting of relapsing remitting MS. So this is not mesenchymal or neural stem cell therapy. This is not designed to induce neuroregeneration or in any way actually affect what is happening within the central nervous system. The whole principle of the treatment is to knock out the immune system that we assume has gone, you know, for want of a better term, rogue, and is attacking the brain and spine. And actually, you know, the stem cells are not the effector cell. They're not actually doing the heavy lifting. The part of the treatment that is doing the work is actually the chemotherapy. And the stem cells really are just there to provide a safety net, a rescue for your immune system to be able to rebuild quickly and recover quickly from the heavy duty chemotherapy. So in terms of what the treatment actually involves, so there are 2 stages. The first is what we call mobilization, which is the collection of the stem cells. People often use the term bone marrow transplantation because historically when hematologists were first doing this treatment, they were actually getting the stem cells out of the bone marrow. But now we use a little bit of a chemotherapy called cyclophosphamide, and that causes the bone marrow to make more stem cells. And then patients inject themselves with this hormone called GCSF, which basically draws those baby stem cells out of the bone marrow and into the blood. And so they're circulating around the blood. And about sort of 8 to 10 days of those injections, we can do a test looking for those stem cells in the blood. And then much like you can see this figure here, much like a dialysis machine, it's a big drip into either elbow, and the blood is kind of filtered and those stem cells are taken away and then just basically frozen down. And then anywhere between kind of 1 to 8 weeks later, depending on logistics and individual preferences, patients then come back into hospital to have the chemotherapy. And then what we call day 0 is the day that those stem cells are given back, again, just like a blood transfusion, so just via a normal cannula into the vein. The chemotherapy differs a little bit, and I'm going to touch on that in a tick. And for the first 2 weeks, people are pretty unwell. So not only do they have next to no immune system, so they're at risk of infection, but they also have all of the usual toxicities of chemotherapy that we're all aware of. And then around that kind of day 10 to day 14 mark, the immune system starts to what we call engraft. So those cells are kind of settled in the bone marrow. They start to proliferate and grow. And sometime around then, people are discharged home. And then obviously we have a very kind of rigorous follow-up to make sure that people are on the right medication to prevent infection, because it takes about 12 months, well, 6 to 12 months until your blood counts come back up to kind of what we would consider, the normal range on a blood test. So Jess showed a similar, much nicer version of this slide. Mine's a bit more basic, but basically, there's been this explosion in therapies in the MS space. And so you can very rightly ask the question, well, why are we still using this kind of real broad brush, approach to treatment? Because, chemotherapy is a very non-specific way of treating an immune system. Well, I guess the one big question has been about the efficacy. So how good is this treatment? Because it is so heavy duty, how good is it at controlling relapses? And so this is purely just looking at the what's called NEDA. So many of you will be aware of this term, no evidence of disease activity. So that means no relapses, no new MRI spots, and no disability worsening. And so now the big caveat to this is that none of these are head-to-head trials. So this is just taking data from lots of different trials, but you'll recognize many of the names in those sort of first 3 quarters of the figure. And so obviously as the disease-modifying therapies have gotten better over time, you're seeing this improvement in the number of people who are meeting this sort of NEDA criteria at the 2-year mark. And then it appears, and again, as I said, there's caveats to all this data, but it appears that HSCT is probably, if not as effective, maybe more effective at the controlling, inflammation, so relapses in those first 2 years. And there are other issues that we've touched on. So, limitations of long-term immune suppression, the way that affects ability to fall pregnant or to breastfeed, risks of infection, and then even ceasing disease-modifying therapy is not always straightforward. There are some Tysabri and Gilenya drugs that we worry about just stopping cold turkey, where you can get a kind of big, almost like a rebound phenomenon, worsening relapse than people may have had at the time of diagnosis. And so there's interest in this idea of what we call immune reconstitution therapies. So can we, on a real simple level, can we try and knock out the immune system? Ideally, we'd be more targeted. And this is what I think is really interesting, some of the work that hopefully we're going to do with Occam's that Tree mentioned before, but can we try and knock out, the immune system to a degree? And when the immune system reconstitutes or rebuilds, does it redevelop in a different way that provides periods of freedom from inflammation, so, remission, beyond how long it takes for the immune system to rebuild? And we'll come back to that a little bit longer when we look at some of the data from our study. So where was one of the dot points that I had up. So basically, you can break down the centers performing HSCT into this sort of more fee-for-service, kind of less selective centers. And I guess the most well-known of that is the Federico Center in Russia. And then there are centers throughout North America and Europe that are running HSCT clinical trials. And then there are some places where it is an approved therapy, but generally, so it's government funded and it's kind of not run in a clinical trial setting, but usually there are still kind of quite intensive government oversight about how it's used and patient selection. So in Australia, as I said, the trial at St Vincent's began in 2010 and was led by John Moore, who's a hematologist that I work with. I actually realised I've put out of date here. So we've now had 66 patients. We've got 67th patient in hospital at the moment. And then we've also had a few patients with sort of other neuroimmunological diseases. There are 2 centres in Victoria and then a couple of other places around the country that are doing HSCT on a bit more of an ad hoc basis. And we're hoping New Zealand will join kind of and collaborate with us as a centre from next year. So this is just showing a little bit about our experience. The first slide is from 2018, and then I'll show you some more updated data. So the figure on the left was in a publication looking at the first 35 patients who had HSCT at St Vincent's. And so on the far left is relapses and new MRI lesions in the 2 years before the transplant. And then on the right is clinical course after the transplant. And so it's like quite striking. You can see that inflammatory activity, so relapses and new MRI spots is significantly suppressed by the transplant. And we saw that, you know, if we look at what we called event-free survival, which is kind of like NEDA, that was basically 70% in our patients who were more relapsing at the time of treatment and more in the realm of kind of 50% in patients who had more progressive MS. This is a little interim review that we did last year. And basically, we could see sort of similar findings. So the proportion of people who were meeting this NEDA criteria was basically about 70% in our relapsing cohort at an average of 4 years. And we've seen this discrepancy between the response to treatment in patients with more relapsing disease versus patients with more progressive disease globally. So this was a study from a few years ago that looked at data from all over the world, and again showed this sort of this difference between patients with more inflammatory versus progressive MS. And so this tells us that the treatment is really working to try and affect the immune system rather than whatever is driving the more progressive components of progressive MS. So currently at our centre, we are taking patients to transplant who have had a relapse or a new MRI lesion despite being on disease-modifying therapy. There are still big unanswered questions in this space. So the first is, how do we, we differentiate between relapsing remitting and progressive MS? And that's obviously a very grey area with a lot of overlap. And so, in people who are really in that kind of middle zone, is there a role for this treatment? Many people will ask, why do I have to wait? Why do I have to have had a new relapse on disease-modifying therapy before I can undergo this treatment? And so that's another big question. Is this something we should be offering earlier and more upfront? How does this compare? What we really need is a head-to-head trial between stem cell transplantation and disease-modifying therapies. And then what is the right type of chemotherapy for this treatment? There's been one randomized trial, but the long and the short of it was sort of marred or hampered by the fact that it had a really mixed control arm. So half the patients had HSCT, and the other 55 patients basically could be on any of these medications. And that was the breakdown. And so basically the government felt that that was too much of a mixed bag to be able to say, yep, this treatment gets TGA approval. Although it did look strongly in favour of HSCT, and it was a positive study, so the number of people who had worsening of disability or time to relapses was far, far lower in the HSCT group. It's basically hasn't gotten off the ground as an approved therapy in Australia. But pleasingly, there are trials underway. So there are 5 studies. COVID has been a big issue in recruitment for these studies, but we're expecting the first of these to finish in about 2024 for publication in early 2025. And so it may be at that point that this will become a more applicable therapy. Touch briefly on different chemotherapy options, and there's increasingly a trend towards more sort of a lighter chemotherapy approach, what we call cyclophosphamide, and you can see that in the blue bars escalating. And I think it's important, obviously, just to touch on complications. So, you know, we've been very lucky at our centre to say we haven't had any deaths, but there is obviously a risk of death when you're using heavy duty chemotherapy, predominantly from infection. There are risks of longer term infections, and whether in fact you may even be causing EBV to kind of come to the surface, which is part of one of the questions that we want to ask with this Occam study. There's risks of longer term damage from chemotherapy, including malignancies, autoimmunity, issues with bone health, and a need for revaccination, and then effect on fertility. And that's obviously a really big issue for our patients. But we've been quite happy to show that we've now had, I think since this was published last year, we've now had another female and 3 men who have fathered children naturally. So there is a chance and hopefully if we can refine the type of treatment, that people will still be able to have natural conception after this treatment. And lastly, the why, and this is still a huge unknown. How does this treatment provide long-term, in some cases out to 6, 7, 8 years remission, even though on a blood test, the immune system looks normal? And these are some of the unanswered questions that we're still trying to unpick. So to summarize, as I said, I think this has a role in the treatment of MS. It can help to answer a lot of questions that we don't yet have. And I'm always happy to take questions and meet with people on a more individual basis to discuss the treatment. Thanks.
Thank you very much, Jennifer, for a wonderful talk. I know that there are some questions on Zoom, so I'll go and have a look at them. But in the meantime, please, do you have questions?
I just ask a question.
Yeah.
Is this like we've had the treatment and then like after 7, 8 years or whatever, we work and they get worse again, can they rehab it, like have it again? Is anyone ever?
Yeah, we haven't done that at St Vincent's, but that has been done internationally, pretty infrequently. But yes, the risk is the more chemotherapy your body's exposed to, the greater the chance of what we call secondary malignancies, because obviously chemotherapies are usually used to treat a primary malignancy, but it's not the case here, but of getting a cancer as a consequence of having more chemotherapy. That's the biggest concern. So yes, so we have had, and it's just a matter of how long you follow people up for. In the first 4 or 5 years, the chance of people needing to go back onto pharmacotherapy or DMT is pretty low, and then obviously it increases every year beyond that.
But that's something people are more likely to do. So that's the end of it, then later on they'll go back on.
Yeah, and so at the moment, about 25% of our patients who have had stem cell transplant more than 5 years ago are back on a DMT now. 75% are off, and then patients in the first 5 years, I think there's it's about less than 1% of people.
So in a way, it's expected that we would end up going back on us.
I think it's still, still the percentages are in favour of not going back onto a DMT, but it's not uncommon, so it's sort of about a quarter. Yeah.
All right. We might take a question from Helen on Zoom. She's been very patient. Sorry, Helen, I couldn't take the question before because I couldn't see the screen, but please unmute yourself and proceed with your question.
Well, my question was really not to this lass here, it was to the previous guy. So I don't know whether I should ask it or not.
Well, then maybe we'll come back to you because we'll broaden
Yeah, okay, I thought so.
conversation.
Yeah,
I'll come
but
back to
it's
you.
interesting about the DMTs going on and off if you're having stem cell. It's very interesting. Thank you for talking to us. Yeah.
Yeah, we'll come back to you, Helen.
Okay, thank you.
Other questions?
Is the age cut-off point still 40 for people with stem cell transplant?
No, at our centre it's 60. The haematologists would probably happily go higher. I think obviously there are, even off the top of my head, I can think of many examples that break this rule, but as a general rule, the number of patients who have got quite active MS in spite of being on treatment over the age of 60 is pretty small. So, and obviously the risks increase with age. And so we've tried to kind of marry up with what most of the other international centres are doing. Yeah.
But I asked my neurologist here in Canberra, because a friend of mine worked at St. Bernard's.
Yeah.
But perhaps I should to see like the own for the clinical trial. And he said, oh no, you're over the age of 40, they won't accept you.
Yeah.
It's
hard to know, but that's probably not, yeah.
But he didn't even bother to contact you and find out whether that, because one of the researchers up there said, oh no, we'll take you, because I actually spoke to someone.
Yeah, right, yeah.
But he just wouldn't refer it.
I think this is, you speak to a really important point about historically this, and I don't, I'm still trying to work out what the full background for that was, but I think historically this has not been accepted by the neurology community. I think that's pretty widely known. I think that's changing. I think partly that's because our acceptance of risk in treating MS generally has increased, so, a lot of these other drugs aren't without risk, obviously stem cell transplant is probably a whole, another level ahead, but, I think our acceptance for risk and realizing that can make tangible outcomes to long-term function, has changed that perception. And so I think partly those, that lack of acceptance has come from the right place, maybe partly it's come from the wrong place historically, but I think you're right that it's really, we're always happy to have that conversation, because I think if people don't get, if you're not provided with the right information, you may people often end up online and, from inaccurate sources. And so I think being able to have that conversation is really powerful, because, I must say it's not something that I had prior to 2017, really any experience. I remember I trained in Western Australia and I came to St. Vincent's and they called me and they said, can you please come and see this patient, when I was a junior trainee? And I was like, what? That sounds crazy. Why is that being done? And then, the more you understand about a field, then obviously your perception changes. But I think, the role for, just having a chat about it is really important.
Taking part in this study, the people who are most the progressive variety, or do you have across the different factors?
Yeah, so we know that the treatment is most effective in situations where someone has had a relapse or a new MRI spot in spite of being on therapy, and generally it's not binary, but generally that's people who have got more in the realm of kind of what we would call relapsing remitting MS. I mean, personally, I'm of the view that it's one condition. So these labels are a bit unhelpful many times. And so trying to pigeonhole people into, like this is relapsing remitting, this is progressive MS isn't always helpful, but generally it's less progressive and more people with, what I would call kind of active in terms of relapses and new inflammation on the MRI scan. And we actually have just done a study with MS Space, which is a big kind of international MS database, trying to look at in patients who have got, what we would call purely progressive MS. And if those patients go on to something like ocrelizumab, so Ocrevus, or have HSCT, basically there doesn't seem to be any additional benefit of the stem cell transplantation. So you're putting patients at a greater risk without an additional benefit. So I would feel very uncomfortable with, you know, with taking someone who fell into that sort of, you know, with that kind of clinical picture.
You've been discussing risk and benefit. What about cost and benefit?
Yeah, that's a really good point. So HSCT is actually very cheap. You know, it's about $35,000. And it's obviously a one-off therapy. Disease modifying therapy can range between about $15,000 to $85,000 per annum. So that is important. The first hurdle though is to prove, I think, efficacy, exactly. And so you need to be able to get, you know, we really just need those phase 3 studies before we can kind of get to that next step. But I think from a health economic point of view, there's a lot in favour of HSCT.
One question is, one of the things about individual comparisons, the people who popularly and get the therapy right, they're at the very worst end or the most extreme end of disease. So essentially the data that you show is an underestimation of how effective it is. Like you're taking people who are being well controlled on standard therapies, and then we're comparing it with a group of people who really failed that therapy, and then we put them on
Yeah, no, that's spot on, David. And you know, I often forget to make that point, but you know, this is a patient population who have been pre-treated with kind of the best of the best, usually, right, by definition. We're trying to answer that question again in collaboration with MS Base. They can do these nifty statistical propensity matching where you can, when you've got like masses of data, try and almost create like an e-clinical trial. So you electronically kind of try and randomize patients. And in that, it does look like HSCT is superior to natalizumab in some metrics and superior to ocrelizumab in some metrics, and in some metrics kind of equivalent. So, but again, I think we still, you know, not unfortunately, I think we need prospective clinical trials. Yeah.
But
Sitting that you're not being seen by the people on.
Oh, sorry.
But I guess what you've just said there is it needs to be contrasted as well with the risk that you talked about. I mean, in a previous career, I worked on a leukemia ward, and that was end-of-line treatment for very specific reasons. I mean, people had been already treated with heavy treatments that made them more vulnerable, but it's a lot major intervention with substantial risk, isn't it?
Absolutely. And not just so, I mean, generally in the hematological setting, they're doing what we call allogeneic transplants, which is a lot heavier duty, but an autograft, you know, so your own stem cells is still a huge burden, you know, in that first 3 months. And so, so obviously there's the kind of very easily quantifiable risks, in fact, you know, obviously like risk of death, infection, etc. But then there's also just the effect on work, time, you know, fatigue. You know, in the first 3 months, I tell patients that they should expect to feel worse, not better. You know, you're expecting to get worse before we're hoping for stability, you know, and I think if some patients feel that they have improvement in some regards, that's an added benefit, but that's not the expectation. The aim is stability, you know, and but that's not an immediate outcome. What is interesting is that it appears very, and this is probably not a surprise, but the strength of chemotherapy that you use makes a massive difference. So just anecdotally, we've recently switched from using that older, more heavy duty chemotherapy beam to what they call cyclophosphamide. And just at a bedside, you can tell that it is a lot easier for a patient to go through. You know, it's still in hospital, you know, it's not a walk in the park, but it is very different. And so finding that balance will be important as well.
Great. Thank you very much. We might take the question from Helen, since she's been so patient. And I think it's for you, Tree.
It just seems a bit silly, I suppose, now sitting here listening to everything else that's being said. But I was just wondering to ask the fellow who did it before, the previous presentation, the Epstein-Barr, is that the virus that gives you glandular fever? I believe I sort of think it might be. I just want if that can be clarified. Is that
Yeah, it's the same virus that gives you
the same? It's the same virus, and I'm just wondering. This is the herpes simplex virus. Is that sort of something that's been looked at as seeing it attacks the immune system? The herpes virus, the simplex one, whether that's part of the package when you get these childhood viruses come through your system which is both of what I haven't had glandular fever, but I've certainly had herpes simplex, cold sores and those types of things. I don't get them so much now. So I just wanted to know whether there was any connection in the research, if that's considered. When I'll leave it to you to answer.
Okay. So Epstein-Barr virus is the virus that causes glandular fever. It belongs to the same family of viruses as herpes simplex.
Okay.
So for many years, Epstein-Barr virus has been put up, as having a role, but so have herpes simplex, and so have other viruses. It's just that a lot of attention is now really focused on Epstein-Barr virus.
Right. Okay. So it's been left behind because it's not relevant.
Well, I'm not sure that it's. I mean, I think we don't like to think of it like this, but sometimes science is like fashion, like things come around. And so at the moment, the fashion's with Epstein-Barr virus, but, who's to know where it's going to go? I think part of the problem is, and I think, David made this point before, that, there's EBV, MS, and we think somehow that they're linked, but we don't know all the steps in between. And it may well be that there may be other viruses as well that may be involved, including viruses we haven't even discovered. So there's a lot to study and a lot to.
Can I just ask you, can you have that Epstein virus in your system but not have ever had glandular fever? Does it always result in getting the fever?
Yeah, so a lot of people who are exposed to the Epstein-Barr virus are actually asymptomatic. So they get exposed to it, they develop an immune response to it, they get infected, and in fact, some of them have evidence of infection in their B cells, right? But when you talk to them, they don't ever recall having any symptoms that would fit having had glandular fever. I think David wanted to say something.
So, herpes simplex virus is my thing as a biologist.
I don't think you want to say that too loud, David.
What did he say? Can't hear him out the back there.
No, you come up because they can't hear you online.
I was saying, so I'm a virologist and herpes simplex is my thing.
Oh, that's good.
Yeah. Well, it's actually not my thing personally. I can tell you I don't have it. But actually, that's what I wanted to say. So the association with Epstein-Barr virus, like I said, something like 85 to 90% of every human on the planet has Epstein-Barr virus. If you have MS, or you look at a group of people with MS, it's almost 100%.
Almost. Right.
Almost 100%. If you do the same numbers on herpes simplex virus, it's about 70% of people who have herpes simplex virus. And people were very interested because it's a virus that does go into the nervous system. The thing is that rate of about 70% is not very different if you look at a group of people with MS. Right. So it looks like it's just something that's very common, but it doesn't look like it's something that is more common in people with MS.
Okay. Well, that's very good clarification. Thanks very much for that.
And
both of you. And
look, people have played this game with so many different viruses, and it's much harder the more common the virus is, right? And so,
well, why are you focusing on Epstein-Barr if it's lots of viruses that are quite common? Is this just this one is easier to sort of break down, or seeing it's more common with people that have got MS?
It's
99% MS people have it. Can you get a blood test to see whether you've got it? I suppose you can.
Whether you don't need to do it.
Oh, right.
Especially, so all of the data says that if you're a person with MS,
you
will have had Epstein-Barr virus.
Well, maybe I've never
very close to.
Never been
it's a 97%.
Yeah. Just I've never had it, so I've got MS, of course. But I've never had glandular fever.
No, neither have I, but I'm positive.
That's what, how did you, but that's what I'd like to find out, whether I was positive or not. As a matter of interest.
Yeah, as a matter of interest, but it's so common. So
Okay,
that's why I
just
don't test.
accepted that
But-
I've got some antibodies there.
Yeah, the answer to your question though is that there is a range of new public people doing new experiments that make this association look stronger.
Right. Well, that's good.
And that's why we're going after it.
Oh, that's good. Look, go for it. Thank you.
On this note, please join me in congratulating our speakers. And I'm now going to hand over to Professor Graham Mann, the director of the John Curtin School of Medical Research, to close this symposium.
Yeah.
Thank you very much, Graham.
Thanks very much, Nick. Look, it's a great pleasure to have been asked to close the symposium. These events are so important for the life of the school and for our not only our researchers to be really closely engaged with people who are hopefully going to benefit from our research, but really to hear from you about your agenda, the things that are front of mind, and to get your feedback about the direction of the research that we're doing. It can't work any other way. This is the way of getting, I guess, not only, it's not just a simple practical thing of, well, if you're more confident in the direction of the work we're doing, you're more likely to participate, to give us your information. But we now know that better research happens when it's co-designed with the people who are likely to benefit. And so this is a really fundamental principle that we embrace here, even though we're a very, I guess, basic orientated research institute. We're absolutely convinced of the power of engaging, of being seen, and of being redirected and helped in our research process. It's something that over a relatively short space of time, with the help of projects like Ohio, this approach is benefiting other forms of research that we do in other areas. It's really, we've learned that it's not only the most efficient way forward, but it's going to get answers quicker and answers that are most beneficial to people who are affected by any health problem, but MS is a classic. So I just want to thank you for coming and supporting the event, and the influence of you in the school here is strong, and we hope to continue with that in the future. Thank you so much.